Yo, procrastinator. What's up? Just getting things set up here. All right. There we go. And one last thing. There. All right. Which Linux distro do you use? So I'm actually on Windows. This is WSL, but the distro is Ubuntu terminal based. I believe it's like how do you get the thing? No, that's not it. I don't think. I don't know. Yeah, it's some kind of Ubuntu anyway. Okay, so we're gonna do some Vulkan today. And okay, I guess I will Vulkan triangle. Understood. I Kalias WSL or had to remove. Okay, why is that? I think when I started out using this, I think Ubuntu was basically the only thing available. I'm not sure. What happened to the camera angle? Huh? Camera angle. What camera angle? What's Vulkan? Vulkan is Vulkan is like program, like graphics programming. It's like I think it's like an alternative to OpenGL, but I actually don't know because I've never actually looked into it. But I have some like super basic experience with OpenGL. Actually, it's WebGL I have experience with, but as I understand, it's kind of similar to OpenGL. But we'll see how this works out. I mean, I've basically done like the triangle on OpenGL. That's the extent that I've tried to do, and like played around with shaders and stuff. But Kex wasn't working for WSL, so I had to remove. Okay, what is Kex? What is Key EX? How do I? Okay, let's just search for like Vulkan tutorial, and let me bring up this thing here. Yes, super basic. Let's see. Vulkan tutorial. Okay, we got vulkan.org. Which one should we choose? Should we do the official? All right. New to Vulkan tutorial, we can change the basics. Metal. I haven't heard of metal. Kronos Vulkan. It's based on Vulkan tutorial. Okay. Why is it called Kronos Vulkan? Okay, so the first off is like I have no idea what I need in order for this to work. I actually like, I mean, obviously you probably need Do you need like a GPU that has like Vulkan enabled or something? Like I have no idea. Nearly all modern GPU generally needed graphics were released after 2012. Okay, so I guess I have. But then there's also things like versions, I guess, maybe, stuff like that. I don't know. You confused me even more. What are you talking about, cold guy? Like, you are confusing me. You are confusing me from the start. You're talking about camera angles. It's like Kex will create a virtual box type window of the distro you're using. Like I had Kali, there was also Kex would have created a virtual window of Kali links. Okay. Yeah. Like, that's the thing. Like, I don't know, like, because I run like Ubuntu, and if I run a command that will run a Linux program that wants to open a window, it will actually open like it will open a window like in Windows, but it looks it's like a different. It's like you know, a weird window. What's your GPU? So I have I believe like 30. It's like RTX 30 something. Camera angle, your game. Oh, I see. Yeah, I mean, yeah, we're still working on that, because I need to figure out how to actually do it, because it feels like I've been walking around in the darkness for on that one. But yeah, we'll return to that after this. This is just a one-off here. Just run Kex in the terminal. It's kind of funny because Kex... Okay, I don't have Kex. Kex... I mean... The spelling there, Kex, it actually means cookie in Swedish. Well, actually, it doesn't mean cookie. It means like... cracker, I guess. A cracker. Okay, anyway. What is going on here? This tutorial will be teacher basic using Vulkan Graphics Computer API, the API by Kronos Group. So the Kronos Group, that's why it's called Kronos Vulkan. I don't think so, cool guy. Install Kex, it's not harmful. Okay, we're kind of derailing here a little bit. Look at this, biscuit. Yeah, that's what I mean. It's, but that's Swedish. Oh my god. Why is it doing this? No, we're not doing that. All right. Anyway, this new adverse verification test to do, which can lead to better performance and less surprising driver behavior compared to existing APIs like OpenGL, Direct 3D. Yeah, so it's like an alternative to this. Yeah, that's what I thought. The ideas behind Vulkan are similar to those of Direct 3D 12 and Metal, which I haven't heard about either. But Vulkan has the advantage of being fully cross-platform, which and allows you to develop for Windows, Linux, and Android at the same time. Okay, that's pretty cool. That's really nice. Wow. Yeah, but I'm not installing that now, right now. I might look at that later. However, the price you pay for these benefits is that you have to work with a significantly more verbose and nuanced API. Every detail related to graphics API needs to be set up by your application, including initial frame buffer creation and memory management for objects like buffers and texture images. The graphics driver will do a lot less hand-holding, which means that you will have to do more work in your application to ensure correct behavior. Okay, so it's like a lower level thing. Where possible, we do take advantage of modern tools to make it easier in this tutorial to work with and learn Vulkan. However, Vulkan isn't meant to be easy. The takeaway message here is that Vulkan is not for everyone. It is targeted as programmers who are enthusiastic about high-performance computer graphics and are willing to put some work in. If you are more interested in game development rather than computer graphics, then you may wish to stick to OpenGL Drive 3D, which will not be deprecated in favor of Vulkan anytime soon. Yeah, I mean, since I'm mostly working with like 2D, very simple games, this is like way above what I'm, what I actually need to do. But I thought it was just, someone requested this, and I thought it was gonna be, since I have some OpenGL like experience, it was gonna be like a fun exercise to try and get something up. Just a basic thing here. OpenGL is hell. Excuse me. I mean, yeah, it's like overwhelming when you get started, I think. And I had a lot of questions when I started out with OpenGL, and still I was like wondering, well, how? Okay, so now I got the basics, but how do I actually use this now to actually do anything? But yeah, I'm gonna guess that Vulkan is the same thing, except it's like 10 times worse. We'll see though. However, understanding the sacrifice of staying in OpenGL is that API will never get the latest features like ray tracing or AI. Okay. OpenGL is maintenance. Vulkan is where research and new features are available. I mean, why not just have a high... I mean, I guess Vulkan is the low level, then you can have abstractions on top, which would then, if they're upgraded, include more things, I guess. Like you can build on top of Vulkan, I guess. I don't know. Another alternative is to use an engine like Unreal Engine or Unity, which will be able to use Vulkan while exposing a much higher... Yeah. But that's like jumping a lot higher though. But there's probably libraries like that. Is it normal to fall asleep? Feel asleep watching tutorials? Yeah, probably. Takeaway message: Vulkan is not for everyone. Blah, blah, blah. Yeah. Okay, let's just skim through this here since people are falling asleep. Prerequisites. Okay. A device driver compatible with Vulkan. I think I have that. That's probably... Well, we'll just say, if I don't, then we can probably not do this, so... Experience with C++? Yes, I have. Although, not like a lot of modern C++, but familiar with RAII initializer lists. I don't know. I mean... Resource acquisition is initialization is a core problem in object lifetimes. Ties the life cycle to object lifetimes. I mean, isn't this just how you do it in C++? Or I don't know. Anyway, initializer lists. I don't know what this means, initializer lists. Okay, whatever it is, we can learn it. Compiler with decent support for C++ 20 and features. I mean, yeah, we could like just install this if we don't have it already. GCC 7+. 7+. I have like 11. No? I don't know. Anyway. Some existing experience with real-time 3D computer graphics. Yeah. You can use C instead of C++ if you want, but if you want to use different linear algebra library, but you will have to use a different linear algebra library. We will use C++. But okay, the thing is, like, I'm supposed to use Zig here. So maybe I should look for like a Zig Vulkan tutorial. Okay. Vulkan tutorial Zig. A Zig implementation of the... Oh, it's an implementation. So it's already done. All codes... this is like a really old version. 4 years ago. I mean, it doesn't matter. But interesting. They essentially do the same thing, I guess. But do they use any dependencies, though? Vulkan Zig? Okay. Vulkan Zig. Vulkan, yeah, so this one seems to be Vulkan binding generator for Zig. Cool. And here's the triangle, but it's cheating if you just copy the code. Yeah, so what I guess we have to do is we basically have to get this Vulkan Zig, and we will follow the tutorial, but we will try to do it in Zig instead of C++. So we essentially just have to translate as we go. Okay, so let's fetch this this library here. We don't need GCC, I don't think. All right, so I'm gonna go in here, make Vulkan triangle. Okay, and I will fetch that. Oh. Okay, now we have Vulkan Zig, and there's that. All right. Okay. Okay, blah 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 blah. Tutorial structure. The GLM library for linear algebra operations. Okay, so apparently we need some kind of linear algebra library. I guess we'll look at that once we need it. If we need it, I don't know. Okay, so this is the tutorial of the rectangle. Let's go. Okay. Let's just see if we can. Let's just see if we can go there. What it takes to draw a triangle. Instance physical device selection. Application start by setting up the Vulkan API through VK instance. An instance is created describing your application and API extensions you'll be using. After creating an instance, you can query for all Vulkan supported hardware and select one or more physical devices used for operations. You can query for properties like VRAM size, device. Okay. VK instance. Okay, let's just try this actually. So we'll go to, I guess we'll go to like, first of all, I'm gonna do this one here. No, that's say cache. All right, and all right. Okay, so let's see. This is the root. We'll just delete everything, and we'll have I don't know, edit Vulkan or something. Wait. Oh yeah, we need to add it to here as well. Let's just delete everything here. The tests. Whatever. Let's keep them. So we can, if we need it, we can create tests, I guess. All right. So Zig Vulkan triangle module. That's the thing. Okay. And then we need Vulkan Zig. Def is dependency. Okay, what is that called? That is called just Vulkan. And I guess we'll do that as well. And we'll take the module. I'm not sure what the module is called, so I'm gonna look that up. You always have to look this up. In the build file, unfortunately, but let's see what it is called. It is called, wait, module. What? Where is the module? Okay, module. Wait. Using package manager, this artifact will obtain by using the dependency name .artifact Vulkan Sig generator. What the hell? Or you can skip all the make sure pass registry. Oh, sorry, you're not seeing this. So I'm confused here. Hey, abbreviated, what's up? Alright, see you later, procrastinator. When open source contribution? I don't know. Hey, what's up, what's up? Well, what's going on? This is weird. So do we need this XML file? Do you know of Togglebit, the streamer? Togglebit has been on here, not recently, but a couple times. I think when I started with Runic. No, we're not pals. I mean, we're not. Oh, sorry about that. We're not like, you know. It's just been in the chat sometimes. Change the title, Vulkan graphic. I'm just gonna do this one. You know, this is not gonna take. I hope it's not gonna. It's gonna take this day. It's not gonna be. It's just gonna be one-off. If I can get it. Anyway, so he's doing a collision detection thing, and I keep thinking, oh, there's so. Well, I don't know about quickly. What kind of collision detection? Cool. What kind of, like, is it 2D? He wants to move the character into the object first, then move it out of bounds by calculating a vector. Yeah. So I actually followed, like, I followed a YouTube series for that, which implemented it in C#, like a physics engine from scratch in C#. And there is like a an algorithm, or well, okay, I don't have it here now, hang on. Alright, so collision. Yeah, so this one here, this function kind of takes care of this. And it's using like things, you also have like restitution, which is kind of like how bouncy the surface is. Both bodies have like a restitution. I don't know, if it's 0, then it's like not bouncy at all, I think. Yeah, and then I also take into account if something is static, it essentially has like infinite mass because it doesn't move. So this will displace both objects depending on, you know, mass and direction and velocity and stuff like that. So it can be you know, a bit evolved depending on, you know, what requirements you have. If you only have if you only have yeah, infinite mass would make a good your mama joke. Yeah, if you only have like you know, ground versus I think I have this one here actually, results collision static. So this is if one of the things are static. It's a lot simpler here. And I just ignore restitution for this as well. So yeah, so this is essentially the thing here. You have the relative velocity, which is like both, well, actually it's just a moving object's velocity. And then here it's like the dot product. Yeah, this looks kind of weird here. It's like this is essentially just 1 because E is 0, so it's like -1. So essentially just, we could just, I mean, yeah, all of this could just replace by V here essentially. So this is the velocity. So the dot product of the velocity on the normal, and then that times the mass. I don't know if does the mass matter here? Okay, anyway, there's a thing here anyway for that. Let's see. No, so this I was on the tangent here actually. Where am I? Here's the Vulkan. I'm trying to import Vulkan with Zig. This whole time I thought it was using Raylib. Sorry. I am using Raylib for my usual projects. This is just a one-off stream where I'm just gonna do like a Vulkan triangle tutorial. Yeah. But my this is weird because over here it says that we need like a XML file. I don't know about this XML file. Maybe we'll learn it in the tutorial. Path to can be obtained several sources from the Lunar G Vulkan SDKs. Can you build the Lunar G package? Registry can be found. Oh, so it's just a file that you can use. So why don't you supply this file? I guess it's because, can we copy it? Okay, so it's just a file that we need, I guess. Oh, shit. This is gonna take a long time. Yeah, I guess this is like a description of the API or something like that. It seems like it's using C types. I wonder why it's not just a C, like a, I mean, I guess this could describe it more with more attributes and stuff. I should have not used NeoVim here on WSL because it's kind of slow when like trying to render this shit at the same time. This is something where I wish Zig, or I mean not Zig, NeoVim was a little bit more optimized. Is when you have, especially, it's like, yeah, it's kind of optimized when you just have a large file that has lines like this. It works pretty well. But if you have like one line that is a lot longer than Zig or NeoVim, I should say, basically just gives up. I guess it's the same with Vim. I don't know. Anyway, now we have this this file here, so let's get rid of that from our buffers. Okay. So we have the file. So how do we actually import this now? Dependency Vulkan registry. Okay, so you pass in like a thing here. Okay, so let's just copy that. Oh shit! Wait, is this for 0.16, right? Yes. Good. So let's just use that instead. There we go. All right, and then we have Vulkan, which is going to be Vulkan. Okay. I don't know why it's complaining about that. All right, now let's go over to here. Let's go to root. Okay. So now we should have Vulkan here, I think. No? Oops. What the hell is happening here? Is it just called Vulkan? Oh, shit. There we go. Oh, okay. Vulkan Zig. That's a weird, errors. Let's restart LSP. Yes, I'm in Sweden. So it's like 11:41 here. All right. No module name Vulkan. Oh, sorry. I need to add it to this module here. Okay, there we go. There we go. All right. Now everything seems to be cool here. So, instance. Create instance. Get instance. Okay. So we have instance. Interesting. Create instance. I guess we need to create an instance. Wait, is this a type? It's a function. Oh, it's a type. Isn't this... It is a type. Funzillas takes forever to reload and build Zig. Yeah. Why is this a type? Like, how can I do anything? VK. Yeah. Okay, I guess I should call it VK. That's the thing. VK, sure. VK. Init. Like, is there any functions in here? Make API version. Gives us a version, okay. Well, yeah, I mean, okay, let's just... Okay, this doesn't give us anything. There's probably a whole bunch of shit in here that we simply don't know how to use, or we can't use it. Okay, so... Weird. Anyway, I guess... I guess we will continue to look at this a little bit. Dispatch tables provides no integration with statically bind, linking lib vulkan. These symbols are not generated at all. Instead, vulkan functions are loaded dynamically. For each vulkan function pointer type is generated using the exact parameters and representatives defined by the specification. A set of dispatch table structures are generated. A dispatch table simply contains a set of optional function pointers to Vulkan API functions and not much else. Okay. To provide more interesting functionality, a set of wrapper types is also generated, one for each dispatch table type. Oh. Base wrapper. So how do we create this, though? Load with a loader. Initializing wrappers. Tailwind is a CSS framework, yes. Yeah, so pointer to a constant is essentially you have a pointer to something that you cannot, that is immutable. Base wrapper loader, where the type of loader must resemble get instance proc adder with optionally having a different calling convention. Instance wrapper functions in signature instance loader, where the type of loader must. Okay. Note these functions accept a loader with the signature of any type. Okay, sure. So base wrapper load custom get instance VK get instance is provided by GLFW. Note that VK instance I don't understand this. Like, do I need GLFW now? What the hell? I mean, I'm gonna assume that we need some kind of Vulkan library, and that's probably gonna be like a C library or C++ or whatever. This one is using like GLFW. Yes. So my squeaky chair is ratting me out. I'm making my own game engine in Zig using Vulkan. Okay, nice. Hello, Mabdo. What's up? What's up? I'm just trying to get started here. I've never used Vulkan before. I am a tiny bit familiar with OpenGL, or WebGL, I should say. But it does have like a lot of overlap as far as I understand. But I mean, I was just like, hey, let's just do a simple triangle demo. But okay, so what I don't understand is where, okay, so first of all, what is GLFW and how does it relate to Vulkan? Like, do we require that? It's an OpenGL library. Okay, now I'm even more confused. Just translate a file that includes glfw3.h and has defined. Oh, it's Vulkan. Okay. I was looking at this is an OpenGL library. That's why I was confused. So we have to, okay, translate. So we translate this file, you say? I mean, I guess we could add this as a dependency. Okay, I'll do this first because I don't remember exactly how we. Was it name equals or save equals? Okay. It's just for making a window. You can use STL window. So is that what instance is like? The instance is the window, or if you used Rust, you would have access to WGPU. Okay. Okay, so we can do like Vulkan, but this is now I have the file now. I have the file. That's fine. But we did this one as well. Are you doing anything like this? Like you take the kind of, I think this is like the API or something, API description, and then the Vulkan, you have a Vulkan Zig bindings library, which I'm trying to use. Are you using this as well? Oh, Vulkan is just like an interface of Vulkan. You create a surface on the window. Okay. But okay, but then I'm also confused because why do you need glfw to create an instance? Is it because glfw has the Vulkan library in it? No, I translated glfw3 header with include Vulkan. Okay, so you never tried to use the bindings library. Okay, I guess Vulkan. How do you do this? I forgot. Add translate C. This is gonna be. Oh shit! I need like the dependency. So glfw dependency. And then this is gonna be include. Okay. Do we need libc? Okay, how do you add? You download the Vulkan SDK. I downloaded. I cloned glfw. Do you have to install the Vulkan like dynamic library or something? There's some kind of error here. Vulkan SDK. Oh. Okay. Hang on. Get distro version. How do I get that? $22, okay. Yeah, I cloned the GLFW library, or I mean I have it in the dependency, and I'm installing the Vulkan SDK now, and make a new file called okay, but I'm essentially doing that. Look at this. I'm adding the file directly, and then on the thing I'm also defining this macro. So it should be correct like this, right? And these error messages don't help me here. What if I just do like build? What will you tell me? Cache check failed. Cache check failed. See, this is GLFW, and we have the include, we have the GLFW, blah 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 blah. What does this actually do? Do I need to specify the file as well? Like, I'm trying to use the build system here. So I have this, you know, translate C, where we have the GLFW as a dependency. This is a dependency defined in the zone file, GLFW. So this will be cloned and put into a directory, right? And then we point to the include file there. Yeah, this is the header file. And then, wait, is the path wrong? No, it's okay, sorry. It's this. There we go. The path was wrong. Okay, so now we have I mean, this is not Vulkan now, this is GLFW. So I guess this will be that. Okay. But like, what? Okay, so now we have that. Okay, but now it's like, okay, do we have like Vulkan? Yeah, but now is the problem here, because now we have to work with like the C types. If we had the bindings, it would be, I guess, I mean, potentially it could be easier, I guess. I mean, we could do this and have the bindings, I think. So if we put the bindings here, and then we have like Vulkan, like this. And then what they said was they had like the wrapper is like, I don't know, base wrapper, load. And then the loader is gonna be create instance. Like this. And that should be our thing. You know, I'm gonna go back here and go back and see if we can use this here. So here's the wrapper thing, and then we can load. Wait, get instance proc address, instance vk instance. Oh, that's what you want. This one. Oh, you made your own wrappers and functions, right? What do you need the bindings for? I mean, it's just to make it easier to work with, I guess. But then it's like, yeah, if I'm gonna follow the tutorial that is for C++ now, I have to do like a conversion. Oh, wait. No, it should have that. The hell? I'm just gonna add these to everything here just to make sure that, I don't know, we probably don't need these, but no, let's just remove it. That's fine. Alright, now there we go. Alright, so right now what, okay, but after that, how do we actually, so that's VKB. Okay, I'm gonna rename it to VKB, sure, why not? And it's doing a bunch of stuff, yes. And then we can call create instance. And now we have an instance wrapper Okay, I guess, you know, I guess we copy this. I have no idea what I'm doing here. Okay, so this is just, you know, convenience. We don't really need these. Like, why do we actually do this? I don't know. Let's just do that. Wait, why don't you have like a load? Oh, it's a proxy. Okay. Well, okay, whatever. Let's just put this over here. Okay, so we have the VKB. We create an instance. What do you want? Instance create info. Allocation callbacks. You need to create a window and then instance. Okay, the reason why I was going for instance first is because when you look at this tutorial, it says the first thing you need to do is have an instance and a physical device selection. Lost electricity, bad climate, bandit, triangle, camera. Also, I'm probably gonna like compile this for Windows. I mean, I could compile it in Linux as well. I guess. Do we need these? When you come to create a surface, you need the window properties. Okay. Okay, we get the window here. Actually, let's. Actually, no, forget it. I'm not gonna do like canonical. I'm just gonna do this. Window use unused constant. Yeah. Okay, we have the window. I want to see if what this actually does. Like, if we do this, do we get anything now? Whoops. All right, I need yeah, I need GLFW. Follow the tutorial, right? Thank you for the help. Okay, so we got that. Now I think we need to link it here. Or not here, but like here. Is it like system library? Yes. I'm just curious what this will do. libglfw3 dash glf Oh my god, okay. Where is it going then? Do I need to like wait, no. Okay, thank you. Where the Okay, I'll try this. I'm just gonna see if I can get this working here. No. It's it's installed. Yeah. LE config being grep library. So is it just called GLFW then? No? This was a long time ago. Or I mean... I don't know. Let's just do that, I guess. This will probably not work, but maybe. Okay. So it's gonna crash and burn now if I try to run this, right? Yeah. With no errors. Could not create a window. Okay, cool. So I need to call init, and then terminate. But this is just gonna terminate immediately, right? So it's just gonna no, I don't think. We'll do this. And then we'll do thread. Wait. No? Time. No? But it's in the documentation. Oh, this is a long time ago. Oh, it's IO. Okay, it's IO now. Everything is in IO now. Sleep. Oh, is that what you need? Okay. Why is that not like working? Window should close. Do we need like an event here? Yeah, poll events, right. So is it window poll events? No. Okay, cool. We can remove this. There we go. Because this is that's exactly how like Raylib does it as well, which I guess they maybe use like ELFW. And now we don't need you. Okay, so let's see now if this works. No? Oh. Do we care about this? If it's non-zero, is it an error? Oh my god, why is this not translated here? Oh, because this is not a bindings library, right. I mean, I guess this window should close is equal, so if this is equal to 1, then it's true, so it should be equal to 0. Hey, there we go. Okay, you can't see it. I'm gonna see if I can get it up there. There we go. Here's our Vulkan demo. Now you don't really see the... Oh, that's weird. I'm not sure if there's something wrong with the capture here. You know what I'm gonna do? I'm actually gonna try and do this. Is it Windows? No, wait. Exit is... Yeah, but now we don't. Now we can't. Okay. Whatever. It works. Cool. All right. So here's our little instance. And now we can also defer this, I guess. Cool. Okay. Hang on. Are they expecting like a bindings library for this? just calling it the stored in. Wait, I might not have seen this. Yeah, this this expects glf3 struct vk instance t found vk.instance. So it's like there's a mismatch of what it expects, and it's like this thing here, type parameter here, but this is from the glfw. Wait, yeah, this is from here, vk instance. Whereas this thing, where we put, no wait, not that way, this one expects, I'm trying to go in here, you know, any type, but then it's loading, it's passing in this, which is an instance. No, it's an enum. Wait. All right, it's a type. It's this type. Anyway, which is a different type. So the but can we map it? Maybe we can make a function. I feel like we're treading down a bad path here, but store in a const m instance. What is this? Field name pointer. So it's a name pointer. It's a string. Or what? Or is a string is a pointer to a string? Or I have no idea. No, this can't be right. Wait. Oh man. Yeah, okay, it is a pointer. It's a C pointer. Okay, but it's right. But what does this one expect though? That's the thing. Like we don't really know. Like field pointer. Wait. Oh, it's just it's the pointer to. I guess it's just a pointer to U8. Then. But it's sentineled. So it's like this. I'll try to figure out what they want here. That's what I'm trying to figure out. And that should just be, because if we have this, and the type of this, yeah, that's what I put here. Okay, but what is the return type? It's a bool? No, it's a nullable something or optional pointer to something. Dispatch field name. It's a pointer to functions? No? No, it's, yeah. It's a function to a pointer. I mean, I guess it would be the same, right? What was it? PK, PF, PFN. Void. But then we don't. Okay, then we don't need that. So we pass this, and we call get instance. Right, p name. It's a C pointer, so I mean, I guess we could probably just pass this along. Perhaps we need to cast it, but we'll see. The struct. Couldn't we cast that as well? I mean, this is weird because this is like a. No, it's not even this. It's VK instance, which is like an enum. And it's essentially 0 here. It says it's passing in 0. So essentially we pass in null, right? We pass in 0, I guess. Or null here. Wait. Yeah. Because that's what we're gonna get. And otherwise, it's a use size, which can be used as an address, right? So I guess this will be int from pointer. We're not gonna get this anyway because it's always null. Right? Okay, so whatever. Let's just do this. We don't care about the instance. We just do this. And we're what's happening? It's initialized as null and then VK create instance sets it. Okay. What's happening here? There we go. Why is it lagging so much? Expected, right, so create instance. Initialize as no destroy instance new in the passage. Okay. So you're an instance handle. So this essentially is probably it's like a U-size version of the pointer, I guess, or is the handle? Because this version here actually gets us a pointer. No, wait. It expects a pointer to a struct, whereas here it's like a number. It's just a U-size, which I would guess is the pointer, perhaps. And then here we can say, okay, so why is this like null here? The instance handle VKI. Wait, no, that's... Yeah, this is weird. Oh, this is not the same instance. Right, this is a different one. Man, this file takes a long time to load. Right, so this is this one, which has the instance, and then we destroy instead. It actually uses the handle to destroy it. Okay. Cool. Alright. So why don't we get this load function? Because it doesn't understand probably the LSP. But now we're getting this. So P create info, instance create info, and allocator callbacks. Okay, let's just continue with the tutorial here. So where is it? We're on step 1. The instance creation. I mean, I guess, like, where's the actual tutorial? Like, this can't be everything, right? Okay, before we start running code, the environment. Yeah, we have. Yeah, fine. That's probably great. Playing with Vulkan. Okay. Yes. All right, init Vulkan main node cleanup. Main run is that okay? Yeah, nothing's happening here. Okay. Interesting to see like modern C++ because I have not really. I've been out of the loop for a long time, and these things I've not seen. I think Endo has been part of it, but I don't know what this is. Oh, C error. Oh wait, no, this is just writing out to error console. Exception probably existed as well. I was like, what is this? What? No, that's just... Wait. That's just the exception. Okay, yeah. Anyway. Resource management. Yeah. Each chunk of malware, yes. Are we using that though? Is Vulkan allocating things? I started Vulkan and C++ moved to Zig a couple days ago. Okay. So are you using Zig normally then? Okay, so app info. Sure. Do we actually need this? And then create info. So this one we do need, I guess. A create info. Okay, I'm just gonna do the create info here. So I guess this will be create info. Instance create info. Do you have any things in here? That I need to worry about? So type is already set for us. The app info we don't have. Do you need the app info? I guess we'll find out. Enable extensions count 0. Enabled layer count 0. Everything else is null. So everything is like default here. Okay, so we don't actually need to do anything there. I think you need to create an application. Okay, app info. Okay, so we do need to set API version, application version, engine version, engine name. Okay. Oh, so engine name is like if you have Unreal or something like that, right? And then application name is just, okay, sure. Let's use their thing. Application version, okay. Make version. Make version. Okay, here we go. So 1 0 0 0. Wait, is this the same thing though? No, this gives us a version. 2U32, okay. Engine version. Oh, I see. So engine is also our own thing. I was thinking like, does this determine like the version of the thing? API version 1, okay. So that is like API version 1, 0. Fine. What else? Nothing else. Okay, cool. So then here we have to say application info is app info. Cool. And then here we simply pass in create info. Allocation callbacks. Let's just see what the thing here says. So create instance. Yeah, it just passes null here. All right. And then if it's not equal to success, we fail to create the instance. Okay. So yeah, we already tried this, so we don't need to do that. Cool. So then we get our instance. And this example code is already written here for us, but let's, yeah, destroy instance we're already doing, I think, yes. Wait. By using the Vulkan HPAI module, we can rely upon the library to take care of create, allocate, destroy, free. So a block of code looks like this can be directly replaced by this. App info, create info. Okay, sure, whatever. Integrating Zig is awesome. Yes, it is. I think you need application creative. Let's see. Pointers, you use appy. Oh, yeah, thank you. There we go. Okay, now we have this thing. We need the window hint. Client API, no API. Huh. Because handling resize windows takes special care looking there. Okay, I guess we'll do this. Wait, the very first call should be in it. Was really designed to create an OpenGL context. We need to tell it not to create an old context with a later call. Okay. So let's do that. So we have our window. Is there like a hint function or something on it? Window hint. It's just okay. Is it only working? Can you only have one window? I'm gonna guess not, but hint is client API. And then no API. Oh, I had it there. Okay. Okay, and then resizable false. Okay. Q. I see. That did not have an error. Okay, interesting. This has no member not alone. So this is weird because this was copied from. I mean, this might be outdated, I guess. I don't know. Instance load, instance handle. Don't we already have the instance? I'm confused. You are the instance. You are the actual instance, right? No? It's called init now. Right. Okay, there we go. There we go. There might be an outdated thing there. Okay. Cool. So let's go back here. Create window, yeah. Width, height, sure. I managed to use the same size there. Yep. Should close, yep. Destroy, terminate. Yeah, I think we're doing that as well. Alright, create instance. Add a data member to hold a handle. Wait, now you changed the version here, 1.4. Vulkan does exist. Some function is older, doesn't work well with RAI, or as we'll talk about later, slang language. Okay, let's change it then. Why did you put that? Okay. 1.4, sure. You have to notice these things. Okay, so there we go, yes. Extensions count. Get required extensions. Extension properties. Extension counts. So okay. Let's just read it. This structure has member name flags, and application points to app info. That Vulkan is a platform agnostic API, which means you need an extension to interface with a Windows system. And the built-on function, which returns the extension it needs to do that, which we can pass. Oh, I see. Okay, so we have to say extension count. Was this for the create info? Yeah. So extension count is equal to get required extension. Wait. Get required. I don't have this. Are you expected to draw a triangle today? That was the hope. This is the hope. I'm starting to kind of not feel that, but we'll see. Get required. Why didn't this show up? Get required instance extensions. There we go. Count. Oh, sorry. This is something, and we'll pass that in here. Okay. Now what are you? You are a U32. There we go. Are you a try or something? Okay, what do you get? You get the extensions. So we get a list of strings. It took me 700 lines of code. Yeah, I'm starting to feel that it's gonna be a journey here. Okay, so we have this thing. Now, we also want to check if the required GLFW. This is so hard to say. Is there a quicker way to say this? Gulfo. Extensions are supported by the Vulkan implementation. Okay, so we have to get what is context? What the hell? Enumerate instance extension properties. Oh, we can do it here, right. Enumerate instance extension properties, okay. So that is a thing. So we go through the count. Okay, this is where I'm out of the loop when it comes to C++. I mean, I'm familiar with some of the patterns here. I mean, we have ranges, none of. So is this like a filtering function? So we have this, and then we have a lambda here, which Okay, so it's essentially going through each extension to see. Oh, I didn't know you could bind like this. Interesting. Okay. Where does I come from? It's this. Okay. So we essentially go through each one of those, check if any of them compared to this extension, if none of them, I guess if none of them are there, then we don't support it, I guess. That's my guess. If we can't match any, it's not supported. Right. I'm just trying to figure out what all that stuff was. So extension properties. Do you need like a buffer? Yeah, you need this buffer here. So is that gonna be the same? Okay, well let's just use alloc here instead. Oops. What is layer name? I mean, I guess it's null since we don't actually. Enumerate instance extension properties. Oh, because they are using RAII. Right. You guess the required extension name for the instance, yeah. So I'm guessing this is 0. Or I mean null. And this is property count. No, wait. So we have the layer name. And then the allocator, right? So we can just pass the allocator. And that will give us the things. Right. So this is much simpler here. Properties. Extension properties. There we go. And I guess this has to be a try now because of the location. Yes. And we also need the allocator. So let's pass in an allocator over here. I'm guessing we can just use our Zig allocator here. Whoops. Okay. I'll put this over here. Yeah. So now we can go through each extension properties. So they were going through actually each like extensions. guess we need to free this as well. Alright. Do we need to... Actually, do you need to be initialized? No? But there's a name here. Okay, I don't know. Anyway. And then we will need to loop through extension properties. And we simply check if they are equal. If all of them are not equal, then so if they are equal, then we continue, right? And if we get out here, if they are not equal, wait, no, if they are equal, we break. If everyone is, so if we didn't break, we go into this else. And here's an error, because then everyone didn't match, or none of them matched. So we have an error. So I will just copy this thing here. And then we can log this. All right. And also, I guess we will exit. Unbounded for loop. What? I mean, wait, so this is just a pointer, right? So, okay, but, okay, fine. Ah. $256. Okay. So I guess we have to make our own like equal thing. If they're not equal, we will have to break to that. If this is 0, we will break. Then we're done. so we can go to the next one. And I guess it will crash if the name is longer than 256, but that's fine. Unbounded for... Yes, it is unbounded. I want it to be unbounded. Okay. U8. Oh. Okay, there we go. I think we have this now here. I mean, we probably want to put it in a separate function, but whatever. Let's just continue here. Okay, so create info. So we have to put the count and the names there in create info. So we have the count. Extension count, and then the names of the extensions. And of course, can we just do a pointer cast here? No, we can't, because okay, I think instead, okay, I did all this crap here. Instead, we probably want to just no, because that's this is unbounded pointers as well. I mean, yeah, so then we can just do a pointer cast here, I think. Okay. Okay, so let's continue. So there's the thing. Other thing, missing piece, layers to enable. Here's what we'll talk about. Enable validation layers, which is one of the most useful and important layers to enable for any project. We'll talk about this more depth next. Leave this empty for now. We've now specified everything Vulkan needs to create an instance, and we finally create the instance, right? As you'll see, the general pattern object function parameters in Vulkan follow is pointer to struct with creation info, custom allocator, callbacks always ignore this tutorial is optional if you're using the default. Pointer to the device instance or context in which the constructor depends. Returns the pointer to the constructed object. If everything went well, the handle to the instance was returned. We can check that everything's working by use of C++ exceptions we can use. If you can't use it, turn off no exceptions. Then, okay, we might have to do this, right? The calls return a tuple with a result and a return object. Oh. Well, no, because we have a binding, so that takes care of that, right? Yeah. Okay. But I guess the binding might tell us that we have to put that define or something, or maybe they do it. I don't know. Okay, anyway, let's continue. Calls return a tuple. Okay. I mean, we haven't done the physical device thing yet. Like, are they just throwing that in here all of a sudden with no explanation? It's on later parts of the tutorial. Okay. Encounter results incompatible driver. Okay. Should we try it now? Like, if we just try this, if we run this, what will happen? We get a error, of course. Undefined symbol vk get instance proc adder. Oh yeah, so I did install the Vulkan SDK, and if we go to SIG here, maybe just Vulkan. Okay, that worked. And there we go. Here's our little thing. It's no errors reported, so great. Cool. All right, let's continue. Right, so we don't need to worry about this, I guess, because we didn't encounter an error. Yeah, Solocorium. Whoa, whoa, whoa. If you look at checking for extension support, did we already do that? One of the possible error codes. If I terminate, the error comes back. What if we want to check for optional function? Okay, I don't care about optional functionality. Everything seemed to work anyway. So what are the validation layers? Actually, you know what? No, because if it's optional, we don't need it, right? Yeah, so let's just go continue here. What are validation layers? The Vulkan episode built around a minimal driver overhead, one manifestation of the goals, very limited error checking, and API by default, even mistakes, some people setting numerations to incorrect values or passing null pointers to required parameters are generally not explicitly handled beyond simply loss type checking, and will simply result in crashes or undefined behavior. Because Vulkan requires you to be very explicit about everything you're doing, it's easy to make many small mistakes, like using a new GPU feature and forgetting to request it at a logical device creation time. However, that doesn't mean that these checks can't be added to the API. Okay, Vulkan introduces an elegant system for this known as validation layers. Validation layers are optional components that hook into Vulkan functions and also apply additional operations. Common operations and validation layers are checking the values of parameters against the specification, detecting misuse, tracking creation destruction, object final resource leak, checking the thread safety, tracking threads or calls original from logging every call in its parameters, stand output, tracing Vulkan console profile. Okay, I don't think we need to worry about this. Right. So you pass a pointer, okay, or you pass this thing here instead. Okay, using validation layers. I don't really care about this, I don't think. Using extensions. As already mentioned above, extensions already also need to be enabled by the name, but here you have to distinguish between instance and device extensions. We'll first create a get required instance extensions function that will return a list of required instance extensions. Okay, so we need to actually enable them now. So we have the required extensions, and we've make sure that they are supported, and now we actually need to like actually enable them, I guess. So, but didn't we already do that? Because that's what we did in create info, right? And this thing, we already did this, I think. I mean, this tutorial, I'm starting, anyway, I'm not gonna bash, okay, anyway, so this is just another way to do the thing we already have. essentially just creating, getting a list of, well, this gets a vector of, it's basically a dynamic array of strings with a known length. Okay, and this one is like the thing we already saw, that we already did. We'll check if they are available. Yeah, so this one was the thing we already did. Yeah. Now the run the program in debug mode and shared error does not occur. This doesn't look at the fact, fundamental instance creating info. Struct instance to include the validation layer names, extension names. Yeah. So we already did this. If the check was successful, okay. Message callback. The validation layers, yeah, I don't care about this. I mean, we might have to do it at some point if we're running into a lot of issues, but like, yeah, I just want to get a working thing here for now. Man, this time flies. Okay. Cool. Configuration. There's lots more settings. Yes, I would believe it. Behavior of validation layers, flags, blah 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 blah. Okay. Physical devices and queue families. Selecting a physical device after initializing mobile library. We need to look for and select a graphics card in the system that supports the features we need. In fact, we can select any number of graphics cards and use them simultaneously. Oh, really? But in this tutorial, we'll stick with the first graphics card that suits our needs. We'll add a function, pick physical device, and add a call to it in the init vulkan function. Pick physical device. The graphics card that we'll end up selecting will be stored in physical device, add as a new class member. Okay. Listing the graphics card is very similar to listing extensions and start with querying just a number. Physical device. Okay, so it's the same thing here. So we'll query we'll get physical devices. Is this after? Oh, this is from instance. Okay. So physical devices, query, no, enumerate physical devices, alloc, okay. If it's empty, oh, yeah, we need to try. If it's empty, then we have an error. Okay. And I mean, I guess we can also now try this as well, because then, okay, so, this makes sure that we actually did find a GPU that we can use. Otherwise, it would be pointless to continue, I guess. Now okay, go back here. Now we need to evaluate each of them and check if they are suitable for the operations we want to perform, because not all graphics cards are created equal. We'll check if any of the physical devices meet requirement, and we'll add to that function. Okay. Suitability checks. I mean, couldn't we just pick the first one? Just for this demo here. It's suitable. I mean, don't we know? Like, does it do any checks before, or is it just returning all of the devices for us? I don't remember if they said that. Supports the features we need. Lists graphics cards similar. Okay. With Vulkan supports, then there's no point. Okay, so they have Vulkan support, I see. But we don't know what other features or properties they have. Maybe. I don't know. Okay, sure, let's just do this. We get the properties, we get the features, and then if it's suitable, we will say that it's a discrete GPU and it has a geometry shader. Okay. Sure, let's take this and we will turn it into Zig here. Physical device, let's just have a pointer. Now this will be, I think. No? What type is this? It's that. Okay. I mean, I guess this is not a pointer then, so we just do this. Okay. And then we'll have like device properties. It's going to be get properties. Interesting. Do we need like the instance or something? Hello, Pollock. What's up? No, yeah, because we're using the instance here to get the things. To get the proper things, and we'll get the physical device, get device. Okay, so maybe we can do like get device, get physical device, properties. Okay, so I guess we'll pass in like the instance. Actually, chillin' and killin'. How is the game engine coming along? Yeah, it's going great. Right now, I'm just doing a one-off, doing like a Vulkan tutorial, just out of curiosity, getting a triangle up. We'll see if I can, because I've been getting help from chat, and I've been getting help from Mabdo, and to get this even started here. So far we have a window So these would be the properties. I'm not gonna spell out the whole thing. And then I guess we also have the features. Okay. Device type. See, this is going to be a direct comparison to how much better Zig is to C++. Boom. We don't need any of that crap. Okay, features, geometry shader, that's a boolean. Wait, bool 32. I wish there was a function on here that made it into a bool in Zig. Equal to true. I mean, we could just return this, but okay, whatever. Nice. Was the engine in STL? No, my previous, or my game is in, the game engine is in, is using Raylib. I guess technically someone said that Raylib actually uses STL, so I guess technically it's true that it's using STL. Oh yeah, and okay, so now we have this function. Cool. And I guess what we'll do is we'll like loop through the devices, and we'll check if we'll just pick the first one that's suitable. If it's suitable, we'll break. We can actually do this. I think you can do it like this. You can do physical device equals this, and then else we have to log an error saying we didn't find a suitable wait, they're doing some super weird things here. So their thing here, they're like keeping track of a score for each GPU. Yeah, I was gonna say, like, I probably don't need it, but I was gonna make sure that we have these features though. So I'm just gonna say, you know, failed to find a suitable GPU. Okay, so there we go. There's our thing. Okay, so now we have a physical device. Okay, and yeah, let's skip all this crap. Supports Vulkan. Properties, API version. Why didn't you put this in from the start? Also, I would invert this. I would say, like, if it's not equal to this, return false. If it's not equal to this. Well, if it's false, return false. If this is less than 1, 3, return false. Okay. Queue family check. It's been briefly touched upon. Every operation, Vulkan drawing, uploading textures requires commands to be submitted to a queue. There's different types of queues, original different queue families. Each family of queues allows only a subset of commands for each. For example, there could be a queue family that only allows for processing of compute commands, or one that only allows memory transfer layer commands. We need to check which queue families are supported by the device and which one of these supports the commands that we want to use. Right now we're only looking for a queue that supports graphics commands, so the code should look like this. Queue families. Okay. I mean, I guess this is also part of this. Queue families. Properties. Unlock. Okay, so we're looking for one queue family that has graphics. If one of them has graphics, then we're good. What's happening? Queue flags. Oh. Okay. Queue flags. Graphics. So if that one is on. Yeah, we should be good. So if this is on, we're good. If one of them is on, we're good. So then we break. Else return false. If we didn't find any that matched, we return false. Okay. Required extensions. We only need one extension, but regardless of how many extensions we need, we must verify that each required device extension access supported. Available extensions. Okay. Device extension properties. Enumerate. Okay. Device extension properties. Oh, here we go. Physical device, layer name, I guess no. Allocator. Okay. And I guess now it's like, okay, well, we need one that matches all of required, and the required is only this. Which is KHR swap chain. Wait, extension name. Okay. Oh man. So we have this, and then we want to say like for each required extension, we want to go through each of our available and check if any of them have the same name. Same issue over here. If they're the same, we will break. What? Oh, right. I'm just gonna say this is a list of names. Okay, so then you would be a string, and that should be oh. Like that. Array literal. Right, there we go. So if they are equal, we are done. Otherwise, none matched. We return false. And then we have features. Optionally supported required features are actually supported. Optionally supported required. Wait. We need to check that all optionally supported required features are actually supported. I'll just skip that. I think. if the physical supports the required features. Why are you throwing in the word optional? Okay, fine, let's do this as well. Features. Wait, we already have features. Features 2. Get features 2. Physical device features. Two. Okay, why not just return it? Why is this different than this? Okay, anyway, so now we have this features 2, and we have to check if so we have to have the shader draw parameters. Wait. What? Physical device shader draw parameters features. This isn't even used. Like KHR. No, that's the same thing. It's the same. Okay, I don't know how to get this done unless we're switching to something else. Do we have dynamic rendering? No. Do we have extended? Like it's here, but I don't, like, there's nothing returning this type. Unless we use, I guess, the original functions. Okay, you know what? Let's just forget about that. Let's just hope that we get something that works. The complete function, great. Okay, logical device and queues. After selecting the physical device you use, we need to set a logical device to interface with it. The logical device creation process is similar to the instance creation process and describes the features we want to use. We also need to specify which queues to create now that we've queried which queue families are available. You can even create multiple logical devices on the same physical device if you have varying requirements. Start by adding a new class member to store the logical device handle in. So it's just called device, okay. Specifying the queues to be created. The creation of a logical device involves specifying a bunch of details. Instructs again, which the first one will be device queue create info. Describes number of queues we want for a single queue family. Right now we're only interested in a queue with graphics capabilities. Interesting. I guess we'll copy this. You're using Vulkan internal function. Was it supposed to be used like this? Okay. Alright. I mean, right. Fine. But this is from their official tutorial, so. Alright, so this would be like instance get queue family properties. Property. No, these are the properties. Right. Q. All right. I see. Q family properties. It's not a good tutorial. I kind of get that vibe. But okay, so then we find the graphics Q family property, Q family properties. Okay, so these are family properties, and this is finding in there. So that should be one of those. So graphics Q family property is going to be we'll look into you, and if we have graphics break P, otherwise we will yeah, what will happen then otherwise? Find if I mean, I guess it has to exist. So I'm gonna say unreachable. Or do you have a default value here? No? Yes? No? Yes? No? There's... Okay. Graphics in index. Oh. So that's just... Okay, hang on. We can also get that here. Graphics index. By adding a range, and we'll break those two. This is such a weird thing. It's like, yeah, we just need to check if this this flag is on. Look at all this code. I mean, I don't know if it speaks to C++ being that way, or if it's just this tutorial. I'm gonna guess it's a little bit of both, but yeah. Okay, and then graphics index we have. And here's our create info. Underclass. Oh yeah, I think. Do we need to pass or put const there as well? There we go. Found U size. Okay, well, let's just uncast that. Q count. Okay, I guess we'll continue. Q priority 0.5. Q count is 1. Q priority. So Q count is 1. Priority. Why is it called F? Or no, it was 0.5. Oh, is it a list? Okay. There we go. Okay, specifying use device features. Next information specifies set features we will be using. These are the features we required support for with physical get features in the previous chapter, like geometry traders. Right now we don't need anything special, so we can simply define it and leave everything to false. Device features, okay, fine. Enable additional. Vulkan is designed to be backwards compatible, which means that by default you only get access to the basic features that are available 1.0. To get new features, you need to explicitly request them during device creation. In Vulkan, features are organized into different structures based on when they were introduced or what functionality they relate to. So, for example, basic features are physical device features. Are in physical device features. Vulkan 1.3 are in Vulkan 1. Okay. Extension specific features are their own structures. To enable multiple sets of features, Vulkan uses a concept called structure chaining. Each feature structure has a next field that can point to another structure, creating a chain of feature requests. Provides a helper template called structure chain. Okay. Fine. That probably has something in the thing. So we need these things, okay. So where are those getting put later? Device create info. Okay. So feature chain. Is there anything with chain in here? No. Here, feature chain. Okay. I mean, we could just do it manually, I guess. Physical device features 2. Oh, I see. This is a chain of different types. Oh, maybe that was what I was missing here before. It's like... wait. Vulkan... No. Enumerate. No? Maybe not. Okay, so these are requested features. So this would be one of them. I'm just gonna name them 0, 1, 2, and 3. And you are that, and then this one is extended dynamic state. Dynamic rendering, shader draw parameters. Yo, borrow checker. Zig finally gave in? No. Never. I don't know. No, but this is I'm basically translating from C++ here to also these. Yeah. And then we're like yeah, we could just do it like this. Requested features. Next is going to be requested features 1. So these ones should probably, they're probably setting some kind of type here, yeah. And then requested features 1. I mean, this could be done in a loop somehow, but whatever. It's just a small amount of things. There we go. Okay, so we have this requested features now, and we need to now create, wait, we need device create info. The triangle, did it come? Not yet. Features. So I guess we just pass in the first one, and then that will, wait, or maybe this is easier. I mean, let's just do this, maybe. No. So that might not be the thing. So in here it's called like, oh, P next. I see. So they start at the end. Well, I started at the beginning. Okay. Well, I guess that's more efficient probably to like say that this next is requested feature 0, this is 1, and this is 2. Fine. We don't need to do that. However, yeah, and then we just say P next is 3. Okay, that's a super weird thing, but okay. What you're doing is not gonna work. It's simply not torture. This is plain wrong. Why don't you want to use much easier tutorial? Okay, so point me to an easier tutorial. I'm just following the tutorial, the official Vulkan tutorial. Okay, so now we have device create info, Q create info count as 1, Q create infos is, I guess it's gonna be this, yeah, enable extension count, required device extension. Wait, is it this one? So it's gonna be 1. I'm just gonna put 1 there, because that's the required. It says required device. Enable the sanction names. I'm just gonna put this over here so we can get it there. No, that's that. Oh, so pointer to and that's an array. Okay. No. So the convention in Zig is like, well, the functions are camel case, fields and variables are snake case, and then types, for the most part, unless they're primitive types like, you know, numbers and stuff like that, are so these are Pascal case. So there is logic, and I mean, yeah, and then you've got screaming snake. That's the, I mean, yeah, that's the constant, I guess. I try to not use those, but I've used them out of like habit. Okay, there. Please work. There we go. Okay. No space case. Screaming, no space case. Yeah, that's the, yeah. That already exists, yeah. Okay, so let's continue. How much further is this gonna take? We got all of these. Okay. I don't want to review anything. I just want to continue. Retrieving queue handles. Okay. So here we can get a queue handle. There's our queue. I mean, do we queue get queue? Oh, these are all just queue. Get queue. Device. Oh, we need to create a device. Right. Right, okay. So we need a device. Device is it this? Create device. Create info. Allocator. No. That's no. Okay. Now we have a device. Now we have a device. What do you have? Are you also an enum? Okay, now I'm confused because there's no like device functions here. Yeah, I'm not sure if Penguin has said hello today. No. No one I don't think anyone used to build Vulkan on Notepad. All what you did is probably not gonna work. Well, I did test Is there like destroy device as well? No. I did test to run it. Well, now I mean, there's like unused things and stuff. Ah, here we go. Here's our first failed to find a suitable GPU. What? Okay. Now we might have a bug here, maybe. API version. These all work. Like if I remove this, I believe it did work. Oh. Still Q families. Is it the Q families? I'm pretty sure I ran this and it did work. Oh, this needs to return true. Wait. Hang on. Let's get those back. Yeah. Hold on. Hold on. There we go. Oh. Wait. But how does it? Yeah. It creates the window even though we didn't find the GPU. Let's do this. Let's move the window thing down after that. Let's put this down over here so we don't get bamboozled by the window showing up. If we found a graphics bit, okay, I know for a fact that this did work before. So it would be very strange if it didn't work. Unused. What the hell? Wait, so if it's equal to discrete, now this needs to be... That's the device type we want, I believe. Hang on, let me double check here. 1 second. So it needs to be discrete GPU and geometry trainer needs to be on, yes. So if it's not a discrete GPU return false. If this is false, we return false. This one I'm not too sure about though. It's just bitcast this, so it's like this is variant. Oh, hang on. No. If the version is less than this, then we return false. I mean, it actually might be less. Oh, it's 1.3. Okay. Why is this 4? I haven't seen any. They might have removed your link. What website was it? It's still... Hang on. If we find a suitable device, we break with this. I'm just gonna return true here. Because this feels weird. Okay, now it did find it. We got a leak, that's fine. Okay, so I mean, the suitability check fails, but we still can request the features and do all this crap over here. So you see, it's supposed to work. How to Vulkan in 2026. Okay. Okay, I guess we'll look at this a little bit. So they're also talking about the instance setup here. It's the same thing as I've seen before. Yeah, this is the same thing except it's SDL instead of GLFW. Device selection. Cues. I mean, this seems very similar, to be honest. It's just that the other tutorial has way more text and is kind of messy. Alright, yeah, that's the same thing as we're doing. Presentation support. Present something to the screen. SDL Vulkan get presentation support. Okay, I don't know. But this uses SDL. But yeah, I guess it's similar. I guess. Create info. Enable features. So this has like different features here, but I'm not sure what the end goal of this tutorial is, though. Rasterization, multiple illuminated and texture 3D objects. Yeah, so that's more advanced. I'm just trying to get a basic triangle. Yeah, it doesn't matter. I know, but the kind of the API calls and the kind of differences will be different a little bit. But okay, I'm just gonna skim through here a little bit. So there's the device, create info, create device, get device queue. Let's see if we have that function. Get device queue. I'm just gonna continue with this, like device suitable thing is destroyed basically. I'm just gonna see if we can get this. So get device queue. See, it's a pointer, so I'm gonna guess this is like the instance has this thing, but it doesn't have it. Maybe we need another instance type? Or a device? Yeah, device proxy. Device wrapper. So we create a device. We get a device, which is just a thing. We want to get the device wrapper, so, or this is the device handle, I guess. And then we get the actual device thing that we can use, which is device wrapper. Load. Okay, this one is called load. Device is device handle, and the loader, I have no idea. The loader, is this similar? Do we need to use like a GLFW function? Instance. This just uses the instance. Wait, I'm confused. I mean, okay, so it might be like device proc adder. Okay, so it's the same thing here. So we probably need a similar function here for device. And you are a device. Okay, and you return also a void function. Yeah. I'm trying to. Yeah, I'm. So this is the logical device, as I understand. I'm trying to get the logical device. Okay. Now. The question is, what do you actually need? You get the device and the field name pointer. So that's the same thing. But now we actually do pass the device in. So we can't just pass null here, I don't think. I think we have to convert this into a pointer. So I'm gonna do switch on device. If this is a null handle, then I guess we'll just call, actually we can return here with null. Otherwise, we will get the thing and we will have to do like a pointer cast, and then or maybe we can just do like pointer from int p dot int from enum. Okay, cool. So now we have that, and now we might be able to get the queue from get queue get device queue. Device handle. Why do we need to pass device handle? Because we already have it here, right? No, we don't. Okay, fine. So we have the device handle queue family index. Okay, but now we can continue. So do I want to continue here or do I want to continue here? I'm just going to continue here because this is what we followed. So sorry about that. I'm just going to try and do this. A graphics index. So that was... Okay, that's graphics index. We already have that. Why is that unknown? It's U size, so we have to intcast. Q index. We can decide ourselves, I guess. So 0. Alright, so here's our queue. I'm gonna guess this is also an enum. Yeah. So that's the handle. I'm gonna call this the handle. Okay, that's our graphics queue. Okay, it's the graphics queue. Sorry. Cool. Alright, Windows Surface. Blah, 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 blah. I'm just gonna go straight to the code. Okay, so you need a surface. Native platform functions. No. Don't think so. We'll see if we need it, maybe. Create info. Okay, so this is the Win32 surface create info. So I guess we need, I don't really know what we need actually. Maybe we do need this. What are you saying? Here's create window. That's just STL. Create surface. A vulkan, but that's an STL function. See, I can't use this API here because I'm using the other one. Create Win30. Okay, so what other alternatives are there? Oh, I see. VI, Wayland. What do I use for WSL? I don't know. Maybe this. Surface, create info. this will give us a handle. All right. Cool. And we need to pass in like instance and stuff like that. I don't know. Let's try with Win32. I'm not sure if that actually if this works at all, but we'll see. Instance. Get module handle. Oh, that's from something else. Get module and a null pointer. Wait, but you need an instance. Can we just pass the instance there? P create info, surface create info. Wait, no. Create window. No, create surface. Surface info. There we go. Oh, here we go. H instance. Get module handle. What is get module handle? It's from... I mean, what we could do is we could go to build, we could also link native. We could... we can do it like this, like you suggested there. But the problem here, though, is that we don't have the paths. That's the problem. We don't have the paths. I guess, I mean, we could... I'm not sure how this works with... I guess the API will make everything available, perhaps. Expose native... yeah. Okay, let's just do this. And we'll add this here. No, now nothing works. What? Why do I get an error here now? Oh, Windows. Okay. So yeah, but this didn't work on Windows anyway. I'm just gonna delete this shit. Yeah, let's just delete this. I don't know, man. Maybe it's... Let's try this. I'm not sure how to use it though, because these examples only work with Windows. Wait, this was not what I wanted. Okay, let's try this. Let's try installing. No. On Windows, so that we might be able to like use it there. I'm not sure how though. I guess it's 64. Okay, yeah. So I'll just put it in one of my places here. I'm pretty sure I had like a place where I would put libraries and stuff. Oh. Okay, let me just make a place. Okay, there we go. And then we need a Vulkan SDK for Windows. Installer. Sure, why not? And I mean, we could switch to SDL, I guess. That's also an alternative. Okay, now we have those installed. I want to go here. And I think we could add include path. Wait, what is path from root? Like, I want like an absolute path, or maybe I need to. Include path. Okay, so I guess it can be like absolute. so this is like put it over here. There's that. I guess we don't need it. We don't need this include path. I guess what we need is the actual binaries. But I'm not sure how to do that on Windows. Like, if this works on Windows, like, library path. Okay, so you can add a library path. I don't know what we would. What that would be. Vulkan 1. Okay, so what? How would you do this otherwise? Like, you would create maybe a symlink in the current directory, probably. So we could do like now this would be vendor Okay. Maybe to find. Oh, wait. We need to change the target. Vulkan age not found. Okay, so then here we can add an include path. Oh, let's change the no. Let's do and so this would be the Vulkan, the vendor Vulkan. Okay, because now we can refer to both the lib, but also include. Okay. Where's that window? Yeah, we'll get to it, hopefully. I mean, there could still be an issue with picking the correct library and stuff. Unable to find dynamic system library glfw. Why is it not searching this glfw? Oh, I spelled it wrong. This is actually, let's do this. No, vendor glfw. So we'll do this, so we'll get different. glfw 3. It's supposed to find 3. I'm not sure where this is coming from. I mean, I could always rename it. But I'm saying it's called 3 here, so I'm not sure why it's saying 2. Maybe if we remove zig cache, zig pkg, it's gonna be the same, I think. Yeah. For some reason it tries to find a thing. Okay. which one is it trying to find? Is it trying to find lib or DLL? I guess both, maybe. I guess we could just copy them as well. You know what? Let's just move over there. No. Move over to there. Okay, copy. No, that doesn't make sense. Okay, I guess that's fine. That's probably good enough. Okay, so nothing happened. I mean, we might have to enable. Okay, let's go back to the thing here. So let's, I guess we'll put this in here. Oh no, I'm just building it, right. I have to do run. There we go. Okay, I have to change my system path. Environment variables. No. Man, the start menu has become such shit. Okay. Let's see. Path. We'll add. So what do we need? Libs. GLFW. I just need to add this to the path environment variable. And I'm not sure if I need to Oh, maybe I need to but the thing should exist here in zig out. Oh. Bin. Yeah, so there's the exe file. So if I just do this, or just exe. No, that didn't work. Okay. I can find it here though. So repos, zig, vulkan, triangle, zig out, bin, exe. Okay. Oops, I shouldn't have closed that. It actually works. I just need to be able to show it to you here. So, hang on 1 second. Multi triangle, out in triangle run. Now, why did I close the window? Huh. Oh, because the browser's in the way. There you go. Here's the Vulkan demo. I guess there was another window showing it as well. Let's remove that. Okay, so here's the Vulkan window. Awesome. And actually, you know what? I think what we can do here is we can do WSL path to Windows. Yeah, there we go. I'll just keep this open here. Okay, so I got it working with Windows now. The problem is trying to get this instance working. This thing over here. So this will now be a... Oh, where's the surface? Surface create info. What's happening? Wingland. Something is not right. Oh shit, I need to get some coffee. Right back. Okay, so how long have we been here? We've been here for 4 hours. we have a window in compiled from WSL into Windows Target, and I mean, yeah, that works. I'm using a Vulkan bindings library. GLFW translated from this and then dynamically linked in, or I mean, I don't know if it's dynamically, but it's linked anyway. And Vulkan as well. Okay. But the problem now is like For some reason this doesn't work. There's some kind of weird error here. Windows not found. So that's Vulkan. Okay, Windows H not found. We probably have that somewhere, somehow. I mean, doesn't Zig have like Windows? I might actually have it here. Okay. I guess we can do that. Will that work? Just a question. Let's just add all of these, I guess. Maybe. I don't know. Maybe we don't. We'll add one at a time. Which one was that? EXCPT not found. KM. I am confused. I actually have this. Okay, I found it. Oh, God damn it. Wait, was it in shared? No, it wasn't in shared. It's probably the the keyboard. So it was here, tools. Include. Yeah, here it is. So this is Windows. This is. I'm gonna call this MSVC. All right. So let's add that. Why not? Yeah, maybe. What do you mean fix that shit? Okay, there we go. no more errors. So are you happy now? Why am I not getting these types? Oops. Oh, I'm getting an error now. Okay, maybe it gave up. Okay, I'm still getting some issue here. Okay. But now I don't get the error. I mean, I guess it's the same errors as this. So this is the translate C command, I guess. And it's passing a whole bunch of different arguments here. So yeah. So, also what I find is weird because Zig, usually you can... It has like the Windows stuff included. So, normally you don't need to add like the Windows things. This is true by default. Because it's like if I do like Windows I can call where's kernel 32, for example. Let's see that. Create process window, I guess. And now you have a whole bunch of shit you put in here. Man, this reminds me of the good old days. So we can essentially just create a window here. Like this instead. We don't even need, you know, GLFW. Like, why do we even need that? We could just create a window here. I guess at GLFW, I mean, yeah, it does include some kind of Vulkan stuff library. Command line. Oh. Okay. I'm not sure if you can change the target like this. I guess we'll try. Oh. Wait, why is this a type? Oh, right. So here we need like a whole bunch of shit. Like all of this. Can you do that? I guess right. So that would be the pointer. Okay, I'm doing something completely different now, but whatever. Sometimes I just get sidetracked here because I did get stuck. I just want to see if this creates a window here. Expected type, because really I'm trying to figure out how to solve this issue with the Windows thing, and so I'm just trying to get this little example working here. LP title is title pointer. Right, so that's the thing. Like, also this is like a U16, so actually we wanna this. Okay, let's just do like alloc U16, and then actually this will be the actual title, test window title. So this would be the title length. You would be title U16. And then I guess we'll do that. And since it has to be 0 terminated, we have to do a sentinel, the element number, and then this is 0. Okay. Oh, sorry. And now this is U16. Okay, there we go. So we need this. We need like thread, process, stuff and stuff and stuff. I guess we'll get the process. Now that's the handle, so I guess that will be like the ID. No, that's the word. I don't know how to get the... Well, the handle might be... Okay, so this... So the handle... This would be... Get process... This... Get process ID... Thread... Thread. Actually, can we just get the process info maybe? Get process info? No? Okay. Get thread ID. Okay, kernel 32. We need kernel 32. So can we add that here? Can we add that with zig run? Maybe there's something weird when you actually do like zig run, and not like in a build. So I will actually let's try this. Let's try import this test here. Windows. And I will actually go here and remove all this. For now. Actually, this mod doesn't matter. Oh yeah, you don't exist, right? Okay. Now I need to link libkernel, unless it's automatically linked. Oh. Okay, let's move Windows into source. Okay, now we get some other stuff. Test window. So LPC. Okay, let's just use the same name here. Expected bool. Okay. Ah, Could not create window. Okay. Now I don't know if that means there's no description here. Create process W return value. So this will, but okay. So essentially, oops. This isn't important though. The important part here is that we didn't need to do anything here. I think it's because the Zig Zig will actually create these functions for us because of this extern here. So this is kind of the header file. So we don't actually need to include like windows.h or anything like that here. We just need, because Zig has essentially its own header files here. So written in Zig. So everything here is like Zigified as well a little bit. And that will be mapped onto the library, the external library, kernel 32 here. So yeah. I mean, if we could get this working, we could just use this instead of glfw, I guess. So I'm just gonna check here the API. Well, presumably we could do it. Okay, where's the return value here? If it succeeds, the return value is non-zero. Okay. If it fails, it's 0. Okay. So that was the thing. So actually, it's gonna be that. I mean, okay. Well, that was, I didn't run it. Okay, so it like exited and then we got leaks. So what I think we need to do is actually, I don't know if we need to set these. But maybe we do. I'm not sure. Like what if we set these to undefined? Because it would make sense if, yeah, that's, so we don't, I don't think we need to set these. If that was like populated. Stored up makes sense that we actually put a bunch of parameters in there. Okay. Parameters. So application name, we don't care about that. Attributes. Null handle cannot be inherited. Okay. Yeah. Thread attributes. Inherits. Okay. Creation flags. Process creation flags. Okay, I don't think there's anything in here that we need to worry about. Process inherits both air mode, color, basic console, environment block for new process assumed. 16-bit Windows-based application runs on a shared virtual DOS machine. What? Environment? Environment block is the no new process uses the environment to call process. Environment block. Okay, I see. It's environment variables. Current directory. If this is null, same as the current thing, right? Startup info. Yeah. Okay. Size of the structure in bytes. Oh, so that we need to set this. Okay. I think that they're using this to determine the type of the thing. So we should do like size of this. That might have something to do with why we don't see a window or why something goes wrong. What is actually leaking here? Windows. Oh, it's this one, right? There we go. Okay, cool. So I'm guessing it just creates the thing, but then we immediately exit, so it's like cleaning it up. We need to have some kind of polling thing happening, I think. So I think what we need to do then is we need to have like a while loop. And then it's like something window. I'm not sure. Events, poll events. No. Okay. What is this? Desktop. Name of the desktop. Is that required? I think I just put in null there. Is the X offset on the upper left of new is created in pixels, right? Size. Use size. Okay, flags. We have to use this then, I think. So where's the flags? The flags are over here. The flags use size. Count chars. What the hell is that? Count chars if new console windows created. Oh, I see. But that's just for console. Fill attributes. Initial text and background colors of new consoles created. Okay. And that's the flags. Force on feedback. Cursor. Run full screen. No. I guess we could do use position as well. Show window. Show window whenever contains additional information. Specify start use show windows maybe can be any value specified. Show window function. Controls on the windows to be shown. Okay. So we can call show window, I guess. Right. Show. Where's the handle? Like, where's the window handle? Okay. I guess this is 0 then. Oh, I see. So we can provide additional flags here. So let's just do show, I guess. Show. No? Is that not... Okay, let's just use the number it actually is. It's 5. Here we have to say use show window. Okay. And this is 0, this is null, everything here is null. Yeah, it's ignored. Okay. What will happen now? Because now we're saying that we should, it's supposed to be shown. So will it show it? No. Oh, wait. Wait. I'm pretty sure there's more functions in kernel 32 than this one. It feels like there's like a lot of things missing in here. Maybe we just need to, you know, what you can do in that case is you can just make it yourself. Like wait for single object, for example. We don't have this function, so let's just see if we can find it here. All right, here's the function. It's in sync API. Sync API, okay. Do we have this here? No. Okay, wait. We have it in NT, but that's not the same. Seems like. I'm just gonna look in all of these Zig files and see if we got wait for single object. Does not look like it for now. Okay, so what you can do, here's the signature. So you copy that, go over to your place. And then we can whoops, put this over here. And I'll just make this function wait for single object. And we have an H handle, which is, I'm gonna, well, interestingly enough, well, these has to be the same, I guess. Oh, whatever. Standard, maybe not, I don't know. OS, Windows, handle. So that's a handle. And then we have milliseconds, which is a D word. Okay, and then it returns a D word. So also this is extern. Kernel, wait, no. Actually, I don't know where this, which, I guess we'll try kernel 32 maybe. Where is crypto? So this is a different, but here we can see it's like pub extern, name function, then it's just a normal function. Oh, we also need to add this call convention, right? That is right. Call convention with API. I'm not sure if this can fail. But I guess, yeah, we'll try this. Okay, so now we actually have this function because it's in the kernel, Windows kernel, so we can call it. So over here we will now call wait for single object. The handle is, yeah, that's the thing. What is the handle? How do we get the handle actually? Create process. Oh, it's from process info.hprocess. Oh, so it's waiting for the process. I see. Okay. So this would be the process info hprocess. Okay, and then milliseconds, infinite. Okay, there's no infinite here. What the hell is infinite? I mean, I guess it's gonna be the maximum, maybe. Was it U32? It's a D word. Yeah. Okay. So this will give us something back, but I guess the result is not required. And after we close the process on thread handles. I'm not sure why we need to do that. I guess if we want to do something else later or something. Close handle we actually do have, because I've seen it before here. H object. So this is process info H process, and then the thread. Okay. So now I'm following the Windows thing to do this. Oh, here we go. We got something here. Invalid handle. Interesting. Close handle got invalid handle. Oh yeah, because I'm using create process. This is create process W. Oh, the example here is using create process, not create process W. Create process A. Wait, was that a typo here? Yeah. Okay, I guess. What was the issue? Invalid handle. Close handle. $49. Okay, let's not do that then. So I guess, I mean, it's like it's. I'm trying to do this wait here, but it's not. This doesn't seem to do anything. This isn't even. What? It's not even initialized. Pointer to a process information structure that receives identical information about a new process. Handles process must be used with must be closed. Close handle. Caller is responsible for ensuring that the standard handle fields and start before containing valid handle values. Okay. Man! Okay. What the hell? Okay, I'm just gonna do this. Zig, Windows, create window. Wait, this is a window client library? Well, it's pretty old now, but wait, where's Vulkan and stuff? There's like bindings for Vulkan. What version is this? What the hell? I mean, I guess he probably generated this. Oh, we're just using create window here. What the hell? Create window. Of course. It's a macro. Creating a window. Create window X. Okay. I won't bother actually. Okay, create window X. Can I just get this somewhere? So here's that. Oh my god. Okay. I'm gonna guess it's in kernel. So return type is H window. Is that just a handle or? No, that's an actual thing. Okay, well. So we've got D word is U30. Well, it's, I guess we can do this. Oops. Actually, fuck. So int is just gonna be like, wait. That's just gonna be use, is it use size? Let's try it. I'm not sure if that's correct. Okay, create window. And this doesn't have all this crap. So great. I'm just gonna create another function here. So this is extended window style window we can raise it. Okay, I don't think I care about that, so I'm just gonna put 0 there. class name, specify the Windows class name. If a class atom, okay, I guess we could just put null here, maybe, or wait. Oh, it can be one of the system class. What's the, like, the default normal window? Or can I just pass like null? A null terminator thing or a class atom. Seriously. Okay, here we go. Desktop window. What the hell is this? Do I put this in a string? No, that's not. Okay. I guess that's what we put there. I have no idea. Window name. Right, so this would just be the title. Actually, we probably need... No, that's actually a normal U8. Okay, nice. Style, I don't know, let's just put 0 there. 0, 0. Width, height. The parent, let's go back. Style, yeah. That's a lot of text for like setting the position. Okay, parent, handle to the parent to create a child window. Okay, I guess we don't have a parent since that's our only window. So I'm gonna oops. I think what you can do is put this there, because that makes it so that if it's null, then like Zig compiler is gonna fix that for us to get a null pointer there. I'm pretty sure, since it's doing it for other things. Menu, handle to a menu. It can be null if the class menu is to be used. Okay, sure. Why not? Let's just do null there as well. And we'll put you can be null. Instance, handle the instance module associated with a window. Okay. I don't know what that means. Of the module to be associated with a window. I don't know. Let's put this there as well, and we'll see if that upsets the Windows gods here. And then we got LP param, which pointer to a value passed to the window through create structure pointed to by the L param of the WM create message. This message is sent to the created window by this function before it returns. If an application calls create window to create an MDI client window, LP param should point to a client create structure. If I don't know what MDI client means. Window calls create window create an shine window. Null if no additional data is needed. Okay, sure. Let's just put null there. Alright. Null. So that gives us a window, actually, a window handle. And I mean, let's just guess we don't. Let's just return this. Cool. And then over at main, we'll call main 2. So now we have a window. I mean, presumably, we get a handle. So now we get the handle of the window. And in the end, we want to destroy it. Right, create window. I guess it could be null. Wait, why wouldn't you store this somewhere? Get module handle. Oh. We need that as well, I think. Where is that? Get module handle. I see. Actually, we get the optional here, actually. Yeah, so all that's optional, we'll put things there. There we go. All of those are optional. Okay. Oh, hang on 1 second. Alright, I'm back. Okay, you know what? I just thought of something as well. Like the issue that we got with, like, it couldn't find Windows.h and trying to refer to Windows for some reason. I think that was GLFW actually. Yeah, that's right. So we have this thing. I'll put this over here. Actually, I'll put all of this in like Windows lib. Actually, let's put this in Windows lib kernel. Alright. And then Windows. We'll import that. Let's call it WK for Windows kernel. And then I'll have Windows lib will expose. No. God damn it. This. I wish there was a way to quickly import a list of these things. What else do we have? We have LPC string. Was it LP void or something? LP void. We have H window, H instance, H menu. All right. Down here we have extern. I'm gonna guess it's in kernel 32 as well, although it's probably call that module name is optional LPC string, and we get a module. Module handle. Okay. Oh, I see. So they're using like this class thing to make a thing. Okay. So we get so let's do window class. WND. Okay. Don't tell me we don't have this. Hello, Pierito. What's up? Or Pierre. Window class. Why can't I find like the exact name? It's always like Windows class A, Windows class W. It's not the same thing. Okay, but we can't pass it in here. We can't pass the module in. So now we're creating the window. Okay, and there we go. And I guess we'll try and just call this for now. LP sister. Oh, expected this, found that. Okay. Okay, so actually let's use that instead. Expected instance. This gives us a module, and this apparently needs an instance. Okay, I might have thought of this wrongly here. But this is also using the same function though, so it's the same. It's just a pointer, and this sets it to this, so I'm confused. I mean, maybe we should return. Actually, we'll return. I guess we'll return an instance instead. Even though the documentation says you get a module. Or maybe, you know, you're supposed to like convert between them or something. I don't know. Okay. Undefined symbol get module handle. Undefined symbol. Okay, so now we get these things. So where are those? Where do they exist? Like which? For example, this is create window win user. So is that the user library, like win user library, or like how do we know which library this exists in? Win user. Win API maybe? Okay, I guess we'll try that. Where is... Oh yeah, I need to... No? Or do I do it here? Right, okay. Path. No, that's just... I think this is just include. Oh, it's taking like a million years because it's going through like WSL layers and shit. Are we gonna get to this rectangle today? Ah, I don't think so. I mean, the problem really was when you know, we tried to link Vulkan to a window somehow. You know what? You know what? What we can do actually, we can go back to what we had before and just call main instead of trying to do all this. So we'll do this again. But here we will because the problem was this over here, create instance. No, it was over at here, and so here we want a surface create info. Now we're back, maybe. And then we want a win32 create surface info. Okay, and the instance we can actually now get because we can import our Windows kernel library. Okay. We also have to make the GLFW work, but let's do one thing at a time. So this will now be the get module handle. Okay. We also have the window instance. So let's actually look at, go back here. The window instance. GLF will get 32 window. Oh, this is gonna be an issue though, because now GLFW will have to it would have to do this stuff. Okay, we'll try to I'll go to build. Can I please go back to build? Thank you. And we'll get this. And let's do that. And this. Oh. No, wait, that wouldn't work anyway. I'll just remove these two. Okay, so now we get an error here. Windows H not found again. And now we get this weird. Now, if we do this, we get another weird error, I think. No? No, not the target. Translation Vulkan not found. So then we add that. Next issue is this weird issue that we couldn't solve. Yeah. I think it's all because we're trying to use Win32 and then we need all this other crap and then this fails for some reason. I don't, like, we can't see the reason here. It doesn't show us the actual reason. It just says that this command failed and we don't get anything. Well, there's a seg fault. So we could, what we could do is maybe we could check if there's like Zig, a Zigified GLFW library maybe. Maybe that will work. .15 though. I mean, yeah, maybe that will work better. I don't know. Maybe we still run into these issues. Maybe not. We could try this, even though it's 0.15. There might be, like, since it's just a wrapper around this, it might actually work. There's also this one, but I'm not sure how maintained this is. Oh, this is actually, no, that's 0.14. Okay. All right, let's try this. Oops. Have to put git plus. Alright, so now we have that. What is this called? Why can't I go to the file? Okay. ZGLFW, right. So ZGLFW. And there should be a module. I'm gonna guess this is called that, but you never know. So we have to go in and check. That's probably what it's called. Module, yes. Cool. And now we can simply add it over here. I'm gonna remove that. Okay. Oops. Wait, unable to find module? Oh, it's only called, okay, it's called GLFW, right. Okay. Nice. Now, let's go back here. No, root. I'm actually gonna copy this root 2. And then you're gonna be ZGLF. Actually, we do need this. Oh shit. Alright, there we go. Okay. Now, what are these called? Get instance proc address. Okay, so that now they don't have like the VK thing. Now what is this? That's the same thing as before, except, whoops, now this is called a VK proc instead. Okay. No, get device proc address. What the hell? I mean, I guess we could. I mean, yeah, we could just define this, I guess, ourselves. Actually. So get device and so the instance, this would be the device, I guess. It's not a I don't think it was a physical device. It was a logical device. Okay, let me check. The API. Like, isn't there, like, okay, reference, vulkan. So instance, what? I'm super confused. Get device proc address. Or adder. What the hell? So where is this? Is it on Vulkan? Oh, because GLFW. Okay, so the previous library or the GLFW library does provide this function. So I'm confused why this doesn't, why it's not there. But okay. So there is no library function called this. Oops, that was wrong. No, okay, we already have the instance. But the why can't I go there? Constructor. So this would be a C const, I guess. Is it C pointer or is it C star or pointer C? I forget. Void function. This gives us a void function. So that would be that, I believe. Call conf C. And this is a VK device. Which is what? It's a handle. Forget how they defined it there. Okay, what's the issue here? Is it because it's supposed to be like this? Yeah. Oh yeah, extern. I'm just gonna say Vulkan. I'm not sure what the correct name was, because the library was called like Vulkan-1. Device is then right. So this is going to be pointer from int to from enum. No, wait. This is the wrong. Sorry. No, it's already. This is null, right? So I guess we'll put nullable there as well, or optional. And the name we can pass through. Okay, and then that is what we're using. So we're already using that, so good. Okay. Window yeah, this is the issue here. Because what I was trying to do is I was trying to go to the... wherever this was. No. GLFW. Let's search for whatever this was. Get, yeah, this one. And we can just copy this. This is in native though. So I'm not sure if this is getting linked as well. I mean, I guess it is, since we're using the Windows version. So let's put this over here. Okay, I'm not sure what this macro is doing, but I'm just gonna do this. I think we put 3 here. I'm not sure actually. Let's put 3 there. Function, this returns an H window. And we have a handle which is this thing. Oh, sorry. Wrong language. Window. Oops. Oh, you didn't see that. Oh, it's a struct. Okay. Hello, Penguin. What's up? What's up? What's up? All right. We get a struct here. You know what? I'll just put any opaque here. Now what is this actually? This is window. Oh, that's the window. Oh, that's the window we get from all the way over yonder. That's the window that we get. Wait, where is that actually? Oh, it's this window, right. So actually we need to move this down after we create the window. And this window is that handle. It's a C long. Okay, so it is that handle. Strange. I'm gonna put it as anti-opaque anyway. I live in... Okay, I can't really pronounce that. You live in some place, and you know what? Here's problem with electricity caused by war. Like normal. Hopefully we just got... Oh shit, I'm sorry to hear that. You just got it back. Nice. I mean, otherwise you wouldn't be here. I hope it will end soon. Get back to normal. Or however normal it can be. But yeah. Better, get better anyway. That's why I sometimes go offline for days. Oh shit. Whoops. Yeah, that sucks. But if you have an internet addiction, it could be good for you. Get out and get some sunlight. So okay, so we're here now. Let's continue. How far can we get it before I have to give up here? I don't know. But now we have the create info for the surface. And yeah, that's... I mean, hopefully this all works. And then we have to create this thing. The surface. And that's what we're doing here. Oh, that was actually named the same. And then, are you a pointer or what are you? Yes. Create info, callbacks. Alright, so that's our surface handle. I think. Oh, I'm gonna restart this. So I can go over here. Okay, yeah, that's the handle. Okay, so now we got the surface. We're moving really fast. Takes... okay. Create window server performs exactly as operation. What? Create window surface. Performs exactly this operation with different implementation for each platform. Will now integrate it into our program. Wait, are you saying that we didn't need to do this or what? Wait, I will demonstrate that platform specific extension can be used to create a service on Windows, but we won't use it in this tutorial. It doesn't make sense to use a library called like glfw and proceed to use a platform specific code anyway. Actually has create Windows surface that handles the platform's differences for us. Still, it's good to see what it does. Oh my god, so this was all behind the scenes. Okay, 1 second. Okay, I actually got a little bit more time here. Although I actually need, I need to eat and stuff, but I'm gonna do this. We're gonna do this. create a triangle in Vulkan in one day with all this crap happening. Okay. Okay, so we throw this all away, and then we're calling this instead. Man, okay, I should read more properly. I'm trying to do this as fast as possible to kind of skim through, or as fast as possible, but you know, I'm trying to skim through. Create surface. Where, well, how? Oh, is this from GLFW? Create surface. Okay. So instance is gonna be from enum, I believe. Instance handle. Right. And then are these actually? Oh, I have to. Window is gonna be window. Allocator is the callback, so I think that's just null. Surface. What? Oh, is that the output? I think that's the output. So surface. Right, so this is going to be a U64 undefined. No, wait, it's a U64, and then we pass that in here to get the surface. So that is our surface handle, I believe. I guess we'll just remove all this, and we didn't actually need this. But the thing is, will this work now is the question. Okay, we can actually try to run this now. Or, well, let's start with trying to build it first of all. Not marked public. Oh my god, are you serious? It's not marked public. Oh, I have to call this function. Sorry, this function. I see. Okay, we're good. We're good. Probably other types of those issues as well. Maybe. Terminate. Init. Oh, and this is also try. And you don't have a thing. Cool. This is just create window, I guess. Window hint. Oh, and then we can simply do. Wait. What are you? You're a C int. Okay, I thought they would upgrade to an enum, but nope. Create window surface. Anything else we're dealing with here? GLFW. What else? $44. Oh, this one is wrong. How is this wrong now? It's the same as it was before. Maybe it's the return type? Expected optional. Oh. Ah, they didn't have the optional here. I think the previous type was actually optional automatically. 15 what? Type of null. Oops. Oh, so we could just, I guess we could just pass. I guess we could just use int from enum instance. It's not indexable. Oh, so now that is a question mark. Where's that? 47. Expected type pointer to a otherwise found a pointer. Can you do this? No way, right? No. What the hell? I just want to... Okay, I'm just gonna refill my coffee. Let's see if we can get this working. So this is a pointer to, I mean, it's a many item pointer to a bunch of strings, right? Okay. I guess if we don't have any extensions, and we know that we do require extensions, Wait, no, these are the required extensions. So we don't get any required extensions. I guess we don't have to check this here. So okay, let's just do this instead. And then we don't need to do this thing here. So I'm gonna do if we get this, then these are the required extensions. And then we do all this. And there we go. Oh, wait, shadows? But that's later. Right? Yeah. Fine. Expected option type, found thing. Okay. Create window. So this can fail. So I guess we'll try. Alright. Yeah, that can fail as well. Value ignore. Create window surface. What? VK result. Get window should close. Okay, so this would be window should close. Window gives us a bool, so this needs to be false. All events. Are we done? No, of course not. Failed to link, library not found. Vulkan not found, okay. Vulkan not found. So is it Vulkan -1? There it is? Question mark? Okay, now we're still going through this issue with thing. So I have to launch this from the thing. Oh, I actually get an issue here. I'm gonna say zig vulkan triangle. I get not initialized. Trying to use a null value. Okay, you know what we'll do? Actually, I will do a session.bin. I will map f5 to zig build. No. Well. Yeah, zig build. The target x86 64 Windows, and then I will do cmd and I'm not sure if this will spawn in this, because sometimes I get a weird path thing here. I'm gonna try it and see if it works. Otherwise, I would have to figure out. Actually, we could do this. CMD CWD. How do I set? What we could do is we could do CMD. Yeah, that's. Question mark. Okay, modifies. I think what we can do is we can say cd wself path Windows, and it's gonna be zig out bin, and I think bash, no, sorry. I mean, I guess we could use PowerShell. No, it's gonna be like this. Command, yeah. Command. There we go. Yeah. Okay. There. This gives us this thing. So let's use PowerShell, I guess. PowerShell. Command. Don't need you. So command. What will be the command? The command will be zig out. Because what this is gonna do is gonna spawn this up in the Windows environment where this is gonna work. Because right now I can't really launch it from here. But that's gonna be bin. And then we have this.exe, right? Yes. Okay. So let's source this, and I'll press F5, and it won't work. Actually, you know what? Let's do overseer run cmd. I think that's how you spell it. Yes. And then this is the whole thing. Oops, what's happening? It failed without any output. Do you fail? No? You might fail. Why is it not putting it to stand it out? Oh, sorry. This is a different... Because I'm running this in a separate terminal, which is like PowerShell, and it has a different output. This actually doesn't output anything. What if we exit NeoVim and then we'll go in here and we'll run this? No? Strange. Okay, well, it does fail, but you don't really see, you can't see it. I have to run it in a separate... 1 second. Okay, sorry about that. No, the stream is not over. Sorry, I'm trying to. I was interrupted here. I'm back now. All right. Where were we? So, okay. I couldn't get this to work though, but I can't show like the error log. So, but anyway, it's a complaining about something not being initialized. I'm just gonna double check again what this is saying here. GLFW not initialized. I get like 6 of those. How's the camera boundary going? It's going so, I would say. I mean, it's an ongoing process. This is just a one-off that I'm trying to make here, but with the Vulkan stuff. But yeah, the camera angle is still in process, in progress. I still need to figure out exactly how to have like smooth transitions or have the system set up at all. It feels like I have like a good system to build off of, but yeah, I still need to figure it out. Alright, so it's complaining about not being initialized. I am calling, where is that? GLFW init. This is called over here. Maybe we need to actually call this at the start. Actually, yeah, we probably need to call this over here. Whoops. There we go. I'm just gonna see if it compiles. Okay, it does compile. So now let me try and run this again. Okay, so we got invalid value this time. Could not create a surface. Native window in use, KHR. Okay, I'm gonna take this error message and I'm gonna Google that. And oh my god, what's all this shit? I'm following Vulkan tutorial. Yes, we get this error. Means that window already has a swap chain. A window can only have one swap chain. If you recreate the swap chain, you must either first destroy the old or you must provide the old. Okay. Huh. But okay. That's weird. Native window. Maybe GLFW is not doing this properly. I don't know. Because they said that we put these hints here, no API for example, which should, oh yeah, and the swap chain. I mean, okay, so what if we don't create this surface? Okay, then it works. Okay, so it's when we try to create the surface, that's the issue. Oh, I got a leak. 96. This one. I have a new comment to add priority and use max priority settings, and in build zig check that there's no overlapping with the same priority. Yeah, I actually already have priority. Wait, are you talking about the camera boundary or this project? Okay, I'm just gonna check if that fixed the memory thing. Yes. Okay, cool. Okay, so there's something wrong when we try to make the surface here. Wait, no, we don't do this. Don't do that. We only do this. What is this? Okay. Camera boundary, right. Yeah, so I already added priority to the boundaries. Native window in use, KHR. Okay, let's look at the tutorial. What the hell is happening here? What does this mean? Star instance? Oh, that's a deref, right? Wait. No? I'm so used to dot star being deref that I don't remember that this actually means deref in C or C++. Okay. Why do you deref here though? Is that supposed to be like that? It's supposed to be a pointer, right? Oh, no. Oh yeah, no, we just pass in a number, right? Yeah. Okay, presentation support. Let's look at how we're doing it here, maybe. Swap chain images. Swap chain. To visually represent something to a surface, we need to create a swap chain. It's basically a series of images storing color information that you enqueue the representation engine of the operating system. It's pretty expensive and requires some explanation. Alright, Penguin. Why put effort into Vulkan? Will you write one render Vulkan? No. No, I won't. This is just me being curious about Vulkan, and yeah, just figuring out how to get the basic triangle up. So I've done it. So I can say that now I've done this. Although soon I had my fair share, because this was way more involved. Just getting a thing up that you can actually do anything with, like render anything on at all. It has been quite the journey here. I mean, although I am using, like, you know, a couple of layers that makes it even harder, like using Zig. I'm using WSL, so I have to cross-platform build and all this stuff to be able to do this at all. And so, but yeah, we've come so far. So I really want to just try to make this work here. But this tutorial is actually aimed towards a more complex example. So this one is actually better for us, I think, even though this tutorial is like really badly written. Is it just a skill check? I mean, it's just being curious about what's, you know, I've had a little bit of experience with OpenGL. And then a lot of people were like, hey, Vulkan, try to use Vulkan. And it's just you know, to get more acquainted with what's out there. So I mean, I'm a curious person. Like I like learning new things. And I thought this is just gonna be like a one-off thing where I try to get this up and running and get a triangle up. But this surface thing does not seem to work with us, and I don't know why. I don't know if it's the interesting. They're creating a surface actually up here. Create instance, and then picking a physical device, and then a logical. So interesting. Let's break this out into these functions as well. Let's do a Vulkan demo. Okay, so I'm gonna do, actually this app info, it's a constant really, so it can't be changed. So when I put it here, it's a constant, pointer to a constant. So we could put a app info here. Okay, we can do oops, you didn't see that stuff. Create instance, setup, blah 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 blah. Yeah, so init Vulkan. Mr. Progress, yeah, there's been a little bit of progress. We have a window up now in Windows, which and we haven't really gotten to write anything in it yet. So yeah, I'm gonna have like a cleanup, which will terminate this. Oops, we have a function here. Init Vulkan. So I'm going to add this here. Let's actually just put everything in here for now. And here's the extension stuff. So let's just put this in. Well, here's the base wrapper. We can actually get that as well, but these are the extensions. We could put this in get extension something get extensions. So this would be like a bunch of extensions. These are the required extensions actually. Get required extensions. And what we could do is we could turn those into, we could just turn them into, so this would be like the many pointer. Bad name here, but and then GLF3 extensions will be the actual slice. So actually we could put required extensions here. Right, and I want to store an allocator. Just so we don't have to pass it around. Oops. Actually, I think we set it to like undefined or something. No, let's just set it to this. Fine. It doesn't matter that much. Okay, so then allocator, allocate strings. Actually, these strings are gonna be like this, actually. Sure. N is extension count. And then we return those. Right. VKB we need to store as well. That is going to be the basic wrapper. Or base wrapper. Sorry, base wrapper. Which we will, I guess we'll set that to undefined. Maybe. What do we actually need for that? We need to, actually we could set it immediately. Yep. Okay. So now we'll do self.vkb. There we go. Oh, wait. That's... Sorry. That is the if. Right. Here we go. This is the one we want. So... Extensions I equals... Extension. There we go. Oh, and now we actually do need this here. But now this is shadowing. Okay. I guess we'll call you J. There we go. Cool. Let's see. How many lock do you have in Metroidvania game? How many locations? I mean, if you're counting like areas, like main areas of the game, it's essentially you have the village, which is just one screen basically, and then you have like that's how it is right now. That might change in the future though. And then, I mean, yeah, and then you have like the interiors as well there. But then you have the forest, which is like, you know, the first kind of area that you're in. And maybe the number of screens is maybe like, I don't know, 10, 15 maybe. Something like that. Oh, lines of code. Oh, I see. I don't know actually. It's starting to get up there, but I don't know. Okay, so let's see. So here we're creating the instance. Let's put this in its own thing. I guess, yeah, we'll put you in a thing as well. That will be in the cleanup. Create instance. What I'm gonna do is I'm just gonna return the instance here. We do need the instance handle as well. Do we have like the handle here? We actually do have the handle. Oh, so then we don't really need this other than creating the thing. Okay. So that's right, extension count. So this would be, so the extension count, I think it's just gonna be this here, the required extensions count. So this is gonna be like self required extensions dot extension count, actually dot length. And then extension name is gonna be self required extensions, which we are going to do this to match the type as well. And this is going to be self BKB. All right. Cool. So instance equals create instance, which gives us an instance. VKB be, we already have from the start. Required extensions equal to get required extensions. And we need to try, and we don't need to try there. Great. I have 5,000 lines of code. Now I have to do the interface. My progress is minimal. I have to do the interface. What interface? Oh, the user interface, or the graphical user interface. Yeah, I mean, progress is progress. I mean, sometimes I feel like I'm doing very small progress on the game, but I feel like as long as I can keep going, you know, eventually it's gonna be complete. You know, so that's how I'm seeing it. It's like the puzzles, the infinite number thing. Is like if you add 0.0000001, but you do it an infinite amount of times, eventually it will be infinite. Or, I mean, eventually, that's kind of weird to say in that context, but, you know, it will eventually grow to a very large number, infinitely. So we don't need to do that, we already do that. Physical devices. Right, so this is like just trying to get a physical device. So let's put that in the function. Get physical device. I'm gonna say void for now because I don't remember the thing. Return physical device. And I mean, we could also have, no, get physical device error equals error. No suitable device found. And that is the error that we can get. Otherwise, we get a physical device handle. And if this happens, then we return get physical device error no suitable found. Here we found no device with Vulkan support, so we can return that. Okay, and actually we don't really need this physical devices thing after the fact, so we can go ahead and free that. That's fine. Vulkan demo. So this will be self allocator, or I usually actually do this, so I don't have to change the allocator usage. And this will be self instance. Self instance. Actually, let's just not call this, I guess. Well, whatever. Fine. Okay. So we have this now, and we can go back to our init Vulkan function, and we can say our physical device is going to be, whoops, get physical device. There we go. Actually, this needs to be a try. There we go. And also, this can be an allocation error, actually. So, whatever error you are, we have to get that as well. Although it's becoming a little bit silly here. So I'm just gonna do this because of Like what you really want to do here, if you want to keep this very, you know, very sleek looking, or not sleek, but very like good for the user to see what kind of errors you can get. So you would combine this error with the errors that you can get in each function here. So you would like go in and get the error from this, put it over here. Same with this here, although this one doesn't really have an error right now. So, but yeah, but you can also just do this to infer the type, but this can lead to circular dependency issues, and you know, it's a bit, if you're reading this code, you would want to know what kind of error you can get, because otherwise it's gonna, you have to go in and check every kind of error. Anyway, UI for the game, yeah. There are a few people, there's so few people to code with Zig and Rayleigh. We share the work to interact with them. There is just one to do Metroidvania. Oh, really? Wow. Yeah, I mean, I knew that I was niche, but to be the only one, that's very niche, right? All right, so we have the physical device, sorry. Q, like, so now we have we want to get the graphics Q family property. This isn't even used. I think this is only used for checking if this is, no, actually, right, so the property itself is not used, but the graphics index is used. I'm just gonna check where it's used, because I feel like it's used like multiple places. It's used over here for the Q create info, and then it's also used down here to get the actual Q. So we probably wanna keep this in the thing if we wanna store it. So this would be the graphics Q index, which is what this is a. Let's just store it as a, I think this is a U32, yeah. Because then what we can do is, whenever we do this, this is only to kind of determine where that is. So this would be get graphics Q index. Gives us a U32. We don't actually need the family property, so I'm just gonna remove that actually and do that. Actually, we need P though, and then we'll return the index there. Okay, whoops. Right. Cool. So then we can get that as well. Graphics Q index is going to be try self get graphics Q index. Can be an error as well. Also, we need to do an int cast from usize to U32. All right. Then we need to do all this crap over here. So this is gonna be, this is gonna create the device. Get device. This will get us the device, right? And think we probably need an allocator somewhere here. Maybe, I don't know, maybe not. Graphics index, so we don't need to cast this anymore. Graphics queue in. Oh. What else? That physical device. Okay. So that is the device. We'll keep this here. Device. Actually, I don't think you... No, you are a try. You are a try. Yeah. Alright. And here we get the graphics queue handle, which we don't really use. So I'm just gonna do this for now. Here we have create window. So I guess we'll put that in a thing as well. And we'll probably, yeah, we'll return this. And this will give us, you know, a window. Actually, we get a pointer to a window. Okay. We don't actually need anything for this. But we'll store the window here. No, just create window. Okay, and then we have the surface. Should probably rename everything to create, because we're really creating the things actually. Surface handle. So that's, so this is a U64. And what do we need for this? We need the instance handle. So that's gonna be instance.handle. We need the window and the surface handle we have, okay? And get surface error, which can be yeah, this is the thing, like this could be a lot of different things. This is like the result here is like it can be any of these, potentially any of these errors. So it's like some error, I don't know. So if it's some error, I guess what we can do is we could do the old surface, create surface error is a nullable result and if the result, so now this one is actually, I'm gonna rename this to create surface instead. So if this is not success, we will set this to result and we will return get surface error. And I will say like, well, let's call this VK error or something. Yeah, otherwise, well, it's fine, okay. Wait, no, create surface error. There we go. Okay. Let's go back here, and I guess we can also store the surface as well. And I guess this is just a U64 or something. Create surface. Okay. And I mean, you could also like, we could pass, instead of having self.instance window, we could just pass those in, I guess, as well. But whatever. It's like I'm mixing two different patterns here where, you know, I don't want to, I'm setting the results to self dot, but we could really put that in here as well, you know. Although these one, get device, these make sense that they are called get, because we're not really creating anything, I guess. So whatever. Anyway, so now we have the surface, and then what else? Yeah, so then here's the actual loop. So I guess we'll call this the loop. And it doesn't really need to be a mutable for now, but let's do that. Okay. So there we go. So now we have all that crap there. And now instead of calling that, we will get the demo by saying vulkan demo dot init, and then we initialize. Oops, no, we don't. And now we can also call loop. So there we go. You said it will take 1 hour max. No, I did not. I said one stream. We're still on one stream. I did not say 1 hour. When I never said that. All right. So we also want to do a cleanup. Okay. I mean, I guess, you know, we don't really need this cleanup function. We could just put this over here. That's fine. Okay. So. Cool. Is there anything else we need to do? I mean, do we need to call like close window or something? No? Don't think so. Okay. Can we build this now? Vulkan demo is not pub. Let's fix that. Also, I want to move this to like lib extra. Wait, no, it's pub extern. Wait. Yeah. No, this one we don't need to public, but this one we do. Alright. Now, also we didn't need this, but whatever. Can we build now? No? What's your issue? Expected this one? Okay. Let's do var. Comp time call of external function. What? Call that comp time from here? Loader? Oh. I see. The default value is comp time. I was thinking like the default value would be evaluated at the same time as it's initialized. I didn't realize it was like an actual... but what we'll do then is we'll say here, and we will not put you on the file. We'll just do that. There we go. Are you done now? Okay, cool. One stream, yes. Very important distinction there. Oh wow. I get a whole bunch of not initialized errors now. So, oh, I need to call init vulkan. Yes. Init vulkan. Try. Okay, and now we get more errors. Because we didn't call it before, so the compiler skipped the thing. Expected type, user found use size. Okay, that's an easy fix. So just incast that. Wow, there's a lot more stuff. 106. Create info. What's the issue? Expected, blah blah blah. Oh. I wish there was a better error message for those things. Expected type T found blah 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 blah. Alright, so now we have to try that. Expected device. Oh, that's the wrapper. Hang on. So where's the actual device? Right, that's the wrapper. But this is the wrapper. Like, we are saying that this is the wrapper that we want. So this should be the same thing. Expected type. Oh wait, is this a... No, that does not return an error. 183. Yeah. Expected blah 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 blah. Device proxy with custom dispatch. Found. Device wrapper with custom dispatch. Device dispatch. I don't see the issue. I do not see the issue here. No, device wrapper. Okay, device proxy, device wrapper. Oh. So we actually get a wrapper here and not the proxy. And then you are actually the wrapper. And then no. Okay, and then we're not actually using that, so 58 create surface. You are a U64, which can return an error, so we'll fix that. $187. Expected type C long found. All right. Are we done now? Yes. Okay. So now I will try this again. Okay, we get the same. We get like this not initialized issue, which before was like if we didn't call glfw.init, we would get a bunch of not initialized issues. It might have something to do here, like the wrapper is trying to call a bunch of shit. So before we even have the thing. So actually, I want to set this to undefined. I mean, we could try to actually call init directly here. Maybe. No. No, let's not do that. Let's do let's do this. So vkb equals, oh shit, let's get this back. Oops, wait, where was, wait, why is that? Okay, there we go. Okay, so we do that after you are undefined. Okay, now we get a different error. So we get attempt to use a null value from here. Interesting. Yeah, so we have to do instance first. Why would we get a null value? The create info we could... Yeah, okay, the create info I'm gonna put here. Oh, I see. We don't really... Okay. Actually, then we put it as a thing over here then. Are you a VK created? Yeah. Instance create info. And then we populate that over here. Or we just... No, yeah, we have to actually store it here. Because otherwise the pointer will not work anymore. Also, I'm not sure about this. If this also needs to be stored. Like, or if it's just used once, like this is the instance wrapper, we probably need to store that. I'm just gonna store it here. And by the way, this pattern here by a bunch of undefines, this is not really a good pattern here. You would probably want to have a bunch of nullables instead, or like optionals instead. But I'm just making sure that everything happens in the correct order. So this would be self. There we go. All right. And the app info, I mean, yeah, here we could actually store this as a pointer because this is a constant, so that's fine. Okay, let's see now if we get better results. Okay, I see a window, but then we get like some kind of weird error. Invalid value, VK error, and we get a leak. This guy. I guess we'll catch. No, actually, what we do is we'll do that. Okay, now we get rid of the leak. Okay, so it says invalid value, VK error. So we get this VK error from, I think it's create surface. So what we could do here is we could do catch error. And really we don't need to worry about the error because it's always going to be the thing, but we can log error, VK error, oh, the tag, and then we have the create surface error, and no, actually we could pass the error along actually, so we'll just return the error there. So we get some a little bit of extra information about what error it is. Okay, so yeah, same error as we had before. It's the error native window in use KHR. So now we're back to where we were, but we have a little bit of more organized code. Right, invalid value it says as well from ZGLFW. So interesting. Does that come from over here? Is that coming from like this? Error name error. Okay, so we actually get like invalid value from here. Code glfw. Okay, so invalid value. Let's see if we can find some information about that. So let's go to that's the vulkan stuff. Where did glfw go? I want no, it's the GitHub, I think, what we want. Yeah, so we're gonna search for create surface or not. Create surface. Create window surface. All right. I'm not sure if there's documentation in here. Docs, Vulkan. Create window surface. Instance window null surface. If OpenGL context was created, open surface cannot be created. It's your responsibility to destroy the surface. Okay, sure, fine. Okay, so so that could be the case. Although we are telling it to not create an OpenGL for it, though. Yeah, this, like, we are telling it to do this. Let's just review that real quick here. Whoops. So we create the, where's the window, and we tell it, although this hint here, I'm like, why is this not like, do we need to have this before? Okay, let's try to have it before. Like, because you can't pass any window to it, so it's like, is it and also it doesn't make sense to pass things like this after you create the window. Like, yeah. Anyway, let's try this now. Hey, there we go. Awesome. It works. Now we have a surface. Okay, cool. Now we can continue. Finally. Oh my god. Okay. Let us then continue. So we have the surface. Now we have to query for presentation support. Welcome implementation may support Windows system integration. Does not mean that every device in the system supports it. Therefore, we need to extend create logical devices to ensure that the device can present images to the surface that we created. Since the presentation is queue specific feature, the problem is actually about finding a queue family that supports presenting to the surface we created. It's actually possible but very unlikely that the queue family supporting graphics commands and the queue family supporting presentation do not overlap. But for simplicity, we assume there is such a queue family and bail out in case there isn't. That is, next we'll look for a queue family that has the capability of both supporting graphics operations and presenting to our Windows surface. The function to check for presentation present support is get surface support KHR, which takes the Q family index and the surface's parameters. I mean, so we already have our graphics family index, right? Like graphics Q index. So I'm confused. Like, why do we search for more things now? I guess because of the surface. Like, now we actually have a surface, but I'm very confused, as always here. Okay. I guess we'll make a new thing for this. So let's do, I guess this will be like Q index. I mean, I guess we have to use it as well. So like get graphics, get surface graphics Q index. I'm not sure what this will be. Let's do a U size for now. So what is this? What is this pattern here? Like negating 0? I mean, I guess you would get like the maximum value. Okay, so it's like a way to get like the maximum value, I guess. But here we don't actually know what it's gonna be. So I'm gonna say that this is gonna be a U size. Also, it's gonna be that. Okay. We're gonna do 0 to okay, we have the Q family properties, so we need to store that as well. Q family properties. And that is going to be this. So we need to store, we need to keep that around. Okay. And it's gonna be dot length. There we go, and we get the index, which we could just name I instead. And actually, instead of doing this, we can do that and I. If that is on and get surface support KHR, I'm gonna guess this is on instance. Family index is I. Surface is surface KHR. Which is this enum, so I'm gonna do like enum from int, because this is a U64. Actually, is that a Yes, it is. Okay, good. Yeah, and then we need you. No? Wait, what's happening here? I guess it's an and. No, wait. Sorry. This is the thing we're already doing. So we're getting a surface support. Great. And we found it. So can we just return this now instead? We return that. We don't even need this, and we don't need this. And I guess this can be an error, or we do nullable. We don't need a break. There is some kind of issue somewhere. Oh, there we go. Return I. Right. Okay. Now we have this function, and we can use that later. So, creating the presentation queue. The one thing that remains is modifying the logical device creation procedure to create a queue and retrieve the queue handle. We need to modify the filtering logic to find the best queue families to use as we detect them. Here's how to do it in one function at the device creation functions. So again, we have to go back and modify something for some reason. Okay, so before we looked at, okay, is this actually the same? Hang on. So this is before we're creating the device, right? So that's what we're doing here. But before that, we actually did get the graphics queue index. Oh, it's only used there. So actually, let's get rid of this. No, we might need this, but so actually this guy sets this thing, so we don't need to set it here. Okay, so we do that. Yeah, this is before when so actually we actually just need to modify this instead of creating a new function. So we just need to modify that there. They're tricking us in this tutorial. It's like they're showing us a thing, and then it's like, no, that's not actually where you need to put it. You need to go back and change another function. I think it's like they're trying to show, like, they're trying to be like, they're trying to be, you know, I'm gonna do it like this. If this is not true, then we continue. And if we do all this crap, if this is not true, we will continue. Otherwise, we'll return I. So we can have each predicate in a separate thing. Okay, now we can go back here and remove all this crap, and we didn't actually need to store the families. and stuff, but whatever. Maybe we need it later. Okay, so you're doing this crap over here. We get the Q index. Here's the structure chain thing, which we already have. We have all this crap. Device, create Q infos. Yeah, the Q family, Q index. Yeah, so we have all this stuff. And we create the device and the Q. Okay. So I guess the Q we could store here as well. Q. And the device. I think I'm gonna rename you to like the wrapper, or like VKD, perhaps. Device wrapper, instance wrapper. Yeah, I'm not using that. Okay, you are. So actually, this should. I'm gonna call this init device and Q. And we don't actually get anything out, but we'll set this to init device and Q, because now we have like multiple things happening. So actually this will be self device or VKD equals this. Actually we could just do that. Okay. Take a break. No. Okay, I feel like I'm okay. I feel like I'm 20% done, but I feel like we've got past the sort of kind of one of the difficult parts where it's like actually getting something, you know, compiling at all and getting a window up. That I feel like that's like a major step in this. So now it's just you know, to set up the rendering stuff, which feels it could be a lot, but we'll see. And I'm gonna take a break at some point, but I am drinking water. I feel like I'm in the zone right now as well. But thank you for being considerate. So we got that. Now device is going to be, is this gonna be from instance create device? Yeah. Physical device, create info. Wait, no, we already do this actually. We have the device handle. Is that the device? No, this is like the thing. How do we get how do we get like the struct? That's the wrapper. Load device. Yeah, the proxy. How do we get the proxy? Device proxy, custom dispatch. Wait, there should be device. Right, init handle is device handle, and then wrapper is self-weekending. There we go. There we go. There we go. There we go. We got that. Okay, cool. And then the queue is going to be device queue create queue queue get queue, get device queue. Ooh, family index and queue index. Oh yeah, so there we go. Queue index is the family. That's the family index. So that's, well, this is the family index. This is gonna be this thing that we have over here. Graphics, graphics index. This is a U32. You expect a U32, and then this one is what we decide ourselves. That's gonna be 0. Awesome. Cool. Now we can remove you. Okay. So there we go. Then now we've done that. Next chapter, swap chains, how to allow us to present images to the surface. I'll just BRB 1 second here, and we'll continue. Alright, let's continue. We're gonna get a triangle up today. Okay, swap chain. Interesting. Vulkan does not have the concept of default frame buffer, hence it requires an infrastructure that will own the buffers we will render to before we visualize them on the screen. This infrastructure is known as the swap chain and must be created explicitly in Vulkan. The swap chain is essentially a queue of images that are waiting to be presented to the screen. Acquire application will acquire some image drawn it to return to the queue. How the queue works and conditions for presenting images depend on the swap chain setup. However, the general purpose of the swap chain is to synchronize the presentation of images with refresh the screen. Alright, so it's essentially, right, you have like, it's like the buffers, I guess. Except this is like some kind of abstraction that that you have to learn in order to use it here. Checking for swap chain support, of course, checking for support again. Not all graphics cards are capable of presenting images directly to a screen for various reasons. For example, because they are designed for servers and don't have any display outputs. Oh my god. I think we could probably skip that, right? I mean, we have a fucking window. Enabling device extensions. Enabling the swap chain extension. I mean, why would what? Okay, I'm getting a bit angry almost at this tutorial here. I think we already did this. I think we already do this. Why is it saying this again? Yeah, we already have this. Like, we don't need to do this. If you follow this tutorial, this is already done. Like, this tutorial is, yeah, it's getting on my nerves a little bit. Querying details of swap chain support. Checking if swap chain available is not. Surface capabilities. I'm just gonna skip this shit. Choosing the right settings for the swap chain. Okay. There may still be different modes of varying optimality in the swap chain. We'll now write a couple of functions to find the right settings for the best possible swap chain. There are 3 types of settings to determine: surface format, color depth, presentation mode, conditions for swapping images to the screen, swap extent, resolution of images in swap chain. For each of these settings, we'll have an ideal value in mind. We'll go with if it's available, otherwise we'll create some logic to find the next best thing. Alright, surface format. The function for this setting starts out like this. We'll later passing formats member of the swap chain support details strikes as an argument. Choose swap surface format, and we'll get a vector of surface formats that are available, and we return the first one. We'll later pass the formats members. Okay. Each entry contains the format and the color space. The format member specifies the color channels and types. For example, format EB8G8R8A8 sRGB means that we store the B, G, R, and alpha channels. Why is it in that order? I guess that's maybe closer to, I don't know, whatever. In that order, like closer to the, well, like the hardware or something. I have no idea. Anyway. Because usually you say RGB, but with an 8-bit unsigned integer for a total of 32 bits per pixel. The color space member indicates if the sRGB color space is supported or not using the VK color space KHR ESRGB non-linear flag. Alright, for the color space we'll use our sRGB if it's available, because it results in more accurate perceived colors. It is also pretty much the standard color space for images like textures we'll be using later on. Because of that, we should also use an sRGB color format, of which one of the most common ones is VK format EB8G8R8A8 sRGB. Let's go through the list and see if the preferred combination is available. Okay, it might have to do also with how the data is stored as well, like it's stored in this order instead of RGB first, which also is kind of weird because that's I'm used to as well. Anyway, let's go through this list and see if the preferred combination is available. Available formats, if we have, so we're simply filtering the thing for these conditions. Color space and format. Okay, if that fails, we start ranking the available formats and how good they are. Oh my god, no. Presentation mode. So I guess this will find us the format integer from the, or the format index or something from the available formats. So that gives us the format that we should use. The representation mode is arguably the most important setting for the swap chain because it represents the actual conditions showing the images to the screen. There are 4 possible modes available in Vulkan. Immediate images submitted by your application transfer the screen right away, which may result in tearing. FIFO, the swap chain's queue, where the display takes an image from the front of the queue and the display is refreshed. The program inserts and renders images at the back of the queue. If the queue is full, then the program has to wait. Wait, you take the image from the front of the queue. You know what? I'm just gonna use immediate. I don't really care about this. Okay. Present mode. Email box. What the hell? Relaxed mail. Okay, whatever. Only one major property which will use last function. Choose swap extent. Extent, the resolution, okay, the resolution of the window. Okay, so in pixels, yes. So I guess that's just gonna be a very simple thing. Extent will return a extent 2D. Okay, well, I'm not gonna do this. I'm just gonna take the screen size and that's gonna be it. So create swap chain. Okay, let's now do this. I'm not sure if we need to store that. Whatever. Maybe. Create swap chain. Okay, so surface capabilities is going to be instance or instance get surface capabilities, I guess KHR, yeah, physical device surface. Maybe we should actually store the surface as a surface KHR instead. Because that seems good. Alright. And then surface. Yeah, then we don't need to do this. Alright, so there we go. There we have our surface thing, or the surface capabilities. Oh, we need to try. Okay, and then we have the swap extent. No, wait, the swap extent is simply going to be the thing we need. So swap extent is gonna be swap extent 2D with, I'm just gonna hard code this. Okay, min image count, choose swap min image count. Oh, they didn't go through that before. Aside from this, we have to design how many images we'd like to have in a swap chain. The implementation specifying minimum numbers requires a function. However, sticking to this minimum means that we may sometimes have to wait for a drive to complete internal operations. before you can acquire another image to render to. Therefore, it's all recommended to request at least one more image in blah blah blah. Okay, so we'll do that. Min image count is going to be surface capabilities, min image count plus 1. And here's the available formats. It's gonna be self instance get surface formats. Welcome back, Penguin. All right, surface format count. I guess this is like an output variable. Is that really how the? Is there an alloc version? Yeah, there is. Okay. So there we go. Let's. Oops. All right. And then we have the format. I'm just going to call this format. It's going to be equal to choose format, available formats, and what is a format? A format is something surface format KHR so I guess we'll get a surface format KHR out. Okay. Right, and this was simply going through each format. I'm just gonna say unreachable over here. And then do you actually have a thing? Yeah, so if format is equal is not equal to, it's gonna be B8 G8 R8S, no, A8 U int, I think they said. Pretty sure. E, wait, E B8. Or maybe that stands for enum. B8, G8, R8, A8, sRGB. Okay. If this is not this, then we'll continue. If format color space is not equal to sRGB non-linear. I guess it's KHR, I don't know. Then we continue. Otherwise, we should return the formats. Okay. So now we have all that crap. Now what? Where are we? we're here, so we have this thing now. And that's the min count. Okay, whatever. Swap chain, create info. Oh my god. Okay, so we need this now. I'm just gonna call this create info. There's nothing else that is a thing. Create info. All right. Oops. Oh. So close. Okay, surface. Main image count. Image format. It's gonna be format. Color space. Swap chain extent. I'm just gonna call this extent. Array layers. All right. Image usage. Also, these are probably wrong. Yeah. Whoops. Color attachments. Wait, that's true, I think. Exclusive. Current transform. Choose swap present mode. Wait, we didn't do that. Oops. Present mode. Okay. I just want to format. There we go. All right. So it's probably gonna explain things here. Color attachment. Okay, I don't really care about. I'm not gonna read all this. I'm just gonna, assume this is all good. Swap chain created for old swap chain. Possible there's swap chain because invalid unoptimized while the application is running because the window was resized. In that case, the swap chain actually needs to be recreated from scratch and a reference to the old one must be specified in this field. This is a complex topic. Okay, so because we don't allow resizable, then we don't care about this. Add class members to store the swap chain object as images. Okay, so we actually want to store these things. So let's do that. So we have the swap chain. And we have the images, which is actually a vector or swap chain images. So let's use an array list image. Okay, so we would probably call like create something something. Yeah. This creates the thing, and then we set this to get images. Okay. Wait, so it's not a dynamic list. Okay, I guess we'll find out. Swap chain is equal to is there like a proxy? No. Maybe it's gonna be like self instance or device, maybe. Create swap chain. Alright, here we go. So this is the create info. And then we have null. So there's that. And this can be an error, I think. Yeah. So there's our swap chain. Yeah. Cool. And then the swap chain images equals to swap chain dot. Okay, this doesn't actually have any functions. I guess it's gonna be like self device get swap images alloc. Sure. Like, do we actually need it to be dynamic? That's the question. Because it feels like we're just gonna have these images and then we're done, right? Or I don't know. Let's just do this. Swap chain allocator. We did define that, yes. Okay. You need to be tried as well, I think. Yeah. So there we go. And now instead of have this being a dynamic list, it's actually going to be a this here. The thing is, yeah, and then we also need to free that as well. So swap images. All right. So you return that. Yes. Cool. Almost there. Okay. So how many lines of code? 300. Okay. So according to the guy that actually created, or the person that actually did this already, Mabdo, we're halfway through now. So in about 8-9 hours more, we'll have our triangle. We'll see. Okay, we've got the thing now. Blah blah blah. Okay, maybe we should actually try to run this to see if it still works. Oh, of course we have compilers. 33. Oh, Q family properties. Let's see, 162. Craft rights. Okay, so you just Oh, and then to bool, no? Equal, if this is equal to false. Return I, use eyes. Okay. Index, wait. Right, so we don't need to, we don't do this, we just do that. Okay. Segfault, address 0. Wait. So we do this after the surface. Okay. So we do this over here. Okay, there we go. Great. What else? We're actually not calling create swap chain, so let's also do that. Try self create swap chain. Probably get more compilers, yeah. 271. Oh, it needs to be this. Okay, that's it, I think. Okay, that still works. Great. Whoop, we got a leak now instead. Is it the images? No, we are doing family properties, required extensions. What was the leak? 251 available formats, right? Free available formats, and actually we want to do that after as well. This is probably not gonna work though. This is weird because this is like we're returning undefined for percent mode, which is garbage, undefined behavior basically. But I guess it works anyway, for some reason. Anyway, so the percent mode, yeah, so let's check out what's happening with the percent mode. How do we do that? Where was that actually done? I don't know. Presentation mode. Oh, I see. This is just returning FIFO. I mean, but then they're saying like mailbox is very nice trade-off, allows us to maintain fairly low latency, render new mails as possible, mobile devices where energy usage more important, you will probably want to use FIFO instead. Now let's say mailbox available. Okay, whatever. Let's just use FIFO. Sure, why not? So I mean, I guess they have to be available. So where would that be? Available. This is so weird. It's like they're giving us like bits and pieces. Yeah, they don't actually explain where to get the available presentation modes. So percent mode, I guess it's gotta be this, maybe? No, that seems wrong. You know what? We'll just do FIFO. There we go. And if that doesn't work, we'll choose something else. Okay, we can still run the thing, nothing, no errors, no crash. Cool. Okay, so we got this done. Specifies image array layers. Specifies number of layers each image consists of. This is always one unless you are developing a stereoscopic 3D application. Okay, okay. Interesting. Image usage, color attachment. Okay, okay, let's just skip all this crap over here. Yeah, the old swap chain. The old swap chain. Which is null to start with, so we don't care. We don't need to worry about that. We have the chain images and stuff that we are calling as well, getting that shit. Okay. Retrieving the swap chain images, which we already store. Like, this is so weird. Like, you're saying here, this is how to get the images, and then you have another section over here which is like, the swap chain has been created now, so all that remains is retrieving the handles of images, and then you call this again. Okay, whatever. One last thing, store the format and extent we've chosen for the swap chain images in memory variables. We need them for future chapters. Wait. Store the format and extent. Okay. The format. Okay. Okay, so we need to store that as well. Why couldn't you say this from the start? Okay, I'm gonna stop raging on at this because it's so weird. Okay, so this will be the surface format. It's like they're giving you these bits and pieces and shit. It's so annoying. Surface format. Alright, and this is surface format. Yeah, I constantly have to go back and change a bunch of stuff. And the extent. So I'm just gonna call this the extent. Okay. Good name for a thing, like the extent there. Okay, so now we store that. Very good. What else do you want us to do? We have now set images been drawn to the window. Next step will come to how we can set up the images as render targets, and then we start looking into the actual graphics pipeline web drawing commands. Whoa! Image views. To use any image, including those in the swap chain, in the render pipeline, we have to create an image view object. An image view is quite literally a view into an image. It describes how to access the image and which part of the image to access. For example, if it should be treated as a 2D texture depth texture without any mapping levels. Okay, in this chapter, we'll write a create image views function that creates a basic image view for every image in the swap chain so that we can use them as color targets later on. First, add a class member to store the image views in. Okay, so we'll store this in our dear old fields. Swap chain image views. I'm just gonna call this image views because there's probably nothing else. Yeah. That's gonna be named that. is this going to, I mean, it's a dynamic. They store it as like a dynamic array for some reason, and I'm not sure if this needs to be dynamic, but I guess we'll find out. Man, it's soon like, okay, you probably most people are probably like gone to sleep by now, because we have such difference in time zones here. Parameters for image view creation are specified in image view create infrastructure. The view type, the format, resource range are identical for each of the image views. With the view type, we specify that we are rendering to a 2D screen. If we're wanting to render to a 3D screen or a cube map, those are also options, as is a 1D screen. You can probably guess we'd want a 2D render target in most cases when we're rendering to a screen. Next, we specify the image format. This is how how the color space components are configured, so you get the right color format in your renders. Next, components aren't needed for our swap chain. We'll talk about them in a bit though. The last member is the sub-resource range, which is necessary and we'll talk about shortly. Okay. So we create our views, we have our create info, okay. We assert that we have an, okay, so here we actually, is it to say that we only call this once? We have our create info. At this point, I wish I would just show the whole thing. Okay, and then you set components, sub-resource range. We go through each image and we set what? Oh, I see. It wasn't done. I was like, how is this doing anything? Okay, and then we emplace back. Huh. I've never heard this operation here. Interesting. We emplace back. What the hell does that mean? C+ standard library method used to append an element to an end of the container. So why isn't it called append? Instead of creating a temporary object to copy or move, it constructs the object in place by perfectly forwarding the construct's arguments. Okay, so it's a special type of append, but in the end we're doing an append. Okay. So we essentially just create this image view info. All right, so let's do that. I guess this will be like create image views function. Create image views. All right. So we'll have our image. Oh, we have our create info. Image create info. Image view create info. It's just one image view create info. Right. So we're creating a bunch of create infos, actually. So emplace back, does that actually construct the thing out from Because look at this. These things are not like create infos. They are image views. So we are actually creating the things somehow from these arguments. Okay, so we have to understand that as well. I see. So it's actually, it's also like it's hiding a step here. It's like sort of. So we have to actually, okay, I see. But we have this create info, which we kind of then modify. Okay, so the create info, we have the view type is 2D. We have format is gonna be whoops, take a break soon when I'm done. We have the format. We have the sub resource range is going to be aspect flag bits, color, it's a bool. Wait, aspect flag bits, color, and then these are like in order. So we have to, I have to do this in order here to get this right. So first it's 0, this is 0, this is 1, this is 0, and then this is 1. Okay, that's that. And then we have components is what? RGBA. Okay, so again, this will be so I guess identity. Wait, no, RGBA, right? So it starts with R, identity. Actually, everything is identity. Okay, so can we do like identity here? No. So R identity, G identity, B identity, and A identity. There we go. Wait, so what's the default? There is no default. Right. Well, the default is 0, I guess, but whatever. Because it was saying like you need to do this. Okay. Subresource. What is that? Subresource field describes the image purpose is and which part of the image should be accessed. Our images will be used as color targets around map levels, multiple layers. You can either list all the elements of the subresource as is done in the okay. So we don't need to worry about that. Now we need to do this loop here. So let's do the loop, loop, and we're gonna do images, and we get the image here. All right, this is our image. We are going to say create info.image equals to image. Actually, I think we need to set this to undefined here. Yeah. And then image views is actually, then this one is actually going to be an array list. I mean, we don't technically need it to be an array list, but let's just do it like this because it might be needed later, which is an image view, and we're gonna say that you're empty, and then we're gonna go to init, and we're going to say image views initialize allocator. All right, so we will append the image view. Now the image view is not actually created yet, so we'll create the image view and we'll say I think it's gonna be like device create image view, create info is create info, allocator is null, try, there we go. There's our image view. We'll pass it in here, and there's the thing. Is it anything else we need to do here? I don't think so. Okay, so we got our image view. Now let's call that from init vulkan, init or create image views. Let's compile and try to run this, and it still works. Great. Let's continue. Next thing is gonna be something here. I'm not sure what this is. Graphics pipeline. Oh my god, we're at chapter 2, guys. Or wait, I mean, yeah, we're at the graphics pipelines now, so we're almost done. I'm just gonna fill up my my water here. All right. I'm in the zone. Let's do this. We're gonna get this triangle up here. Graphics pipeline. Over the course of the next few chapters. Oh my god. We'll be setting up a graphics pipeline configured to draw our first triangle. That's just funny. The graphics pipeline is the sequence of operations that take the vertices and textures of your meshes all the way to the pixels in the render targets. A simplified overview is displayed below. We have our vertex and index buffer. So that is similar to OpenGL, where you have like a buffer of vertices and stuff like that, and indexes as well. Input assembler, that word I don't know about, but okay. So that assembles or a triangle, I guess. Vertex shader, which can we'll probably not use this, but I guess this could move the vertices somehow. Tessellation is this thing. I think tessellation is like you can add detail more detail or something like that in the triangle or whatever. Geometry shader, okay, this actually could add geometry here. Interesting. Rasterization is actually drawing to an image. Fragment shader puts color on it. Color blending, I guess, will draw it to the background there, and then frame buffer. Okay, so I mean, a lot of things I already knew here, but I haven't, like these things I've never done, and it's not probably necessary here. So I think also the input assembler, I have no idea what that is. I mean, I'm guessing it's gonna do something to put this in a format that's usable later, but I see. So essentially this, and then we're probably gonna use like this, and then these three, maybe. I'm not sure. Yeah, probably color blending. Okay. So let's see. The input assembler collects the raw vertex data from the buffers you specify, and may also use an index buffer to repeat certain elements without having to duplicate the vertex data itself. Vertex gender. Okay, so I won't read everything here. All right. Stages with a green color are known as fixed function stages. These stages allow you to tweak the operations using parameters, but the way they work is predefined. Stages with a green color. There are no green colors here. They may have changed the thing there, but I'm gonna guess it's the one with blue. Those are the shaders that you can program yourself. No, orange is the programmable. Okay, that's the shaders. Yeah, exactly. Okay. If you've used older APIs like OpenGL and Direct3D before, then you'll be able to change in the pipeline settings at will with calls like blend func, set blend state. The graphics pipeline in Vulkan is almost completely immutable. So you must recreate the pipeline from scratch if you want to change shaders, bind different frame buffers, or change the blend function. This disadvantage is that you'll have to create a number of pipelines that represent all the different combinations of states you want to use in your rendering operations. However, because of all the operations you'll be doing in the pipeline are known in advance, the driver can optimize for it much better. Some of the programmable stages are optional based on what you intend to do, right? So, for example, the tessellation geometry stages can be disabled if you're just drawing a simple geometry. If you're only interested in depth values, then you can disable the fragment shader stage, which is useful for shadow map generation. Okay, cool. In the next chapter, we'll create the first two programmable stages required to put a triangle onto the screen, the vertex shader and the fragment shader. The fixed function configuration like blending mode, viewport, rasterization will set up in a chapter after that. Okay, cool. The final part of setting up the graphics pipeline in Vulkan involves the specification of input and output frame buffers. I guess the vertex shader could be used for like things like camera stuff and stuff like that. Final part of setting up the graphics pipeline in Vulkan involves the specification of input and output frame buffers. Okay. Create a create graphics pipeline function that is called right after create image views in init. Vulkan will work on this function throughout the whole following chapters. Create graphics pipeline. Cool. Shader modules. Unlike earlier API, shader code specified by bytecode format using bytecode format is called SPERV and is designed to be used with Vulkan Kronos API. Okay. It is a format that can be used to write graphics and computer shaders, but we will focus on shaders used in Vulkan's graphics pipeline in this tutorial. Blah blah blah. Vertex shader. Okay, fine. Okay, wait. Maybe I'm actually interested a little bit in the theory here. The vertex processes each incoming vertex, takes attributes, wall precision, color, normal, texture as input. The output is the final position. These values are going to be interpolated over fragments by the rasterizer to produce smooth gradients. The clip coordinate is a 4-dimensional vector. Okay. So this is... Wait. Can you actually have like embedded... No, wait, this... Can you have... No, wait, this is actually shader code. Yeah. I was thinking like embedding shader code in C or something, or C++. Kernel. Okay, how do you pronounce kernel? Kernel. In the kernel. Oh, I see. So we're essentially skipping the vertex buffer step by just having the vertices in the shader. Okay, that makes sense because we're trying to do the simple. So I guess we'll put this in a shader file. I'm gonna put this in like source, vertex. Isn't that no? Well, what's the shader? How do you pronounce perfect? Perfect. Yeah. Extension, file extension. Oh, GLSL, vertex radius dot verge, vert or VSH. Okay. Vertex VSH. Oh, I see. We don't have this. Wait. It's compiling. Okay, there we go. Cool. We got the vertex. I guess we have some sort of syntax here. I'm not sure, like, what is this file type? V? Vertex shader GLSL. Okay, there we go. Maybe maybe we'll move it to GLSL instead. Whoops, no. Okay, there we go. Okay, so we have this crap now. Cool. So we essentially hard code in the coordinates here. That's fine. It's invoked for every vertex. Okay, so this is invoked for every vertex. So essentially, we have to know which index, I guess, it will be. Like, we get the vertex ID. I see. So, right. So in OpenGL, you would access a buffer here, I would guess. I would, if as far as I recall correctly. So you would access, like, you would get an input buffer, like an array that you could access, and then you would use this index to index into that. But here we can simply say we get 3. How do we determine that we have 3 though? I guess that's gonna be when we actually do this later. So here's the fragment shader. which is not the actual fragment shader we want to use, because this just returns red. Okay, I guess we'll start with that. Maybe we can start with that and then we can change it later. That's gonna be more dramatic. So we'll do source fragment. Okay, there's our fragment shader. And I think they have to be in separate sources for this to work. Per vertex colors, right? So we'll do this later. But yeah, compiling the shaders. Oh, they actually put them in the same thing. Shader slang. Okay, I guess let's put it in a slang file. That's funny, because that means something entirely different in Swedish. It means hose. So slang. Okay, we don't actually have this. Why slang? Why not GLSL? Okay, I guess we'll do this. Vertex. There we go. So there's our full thing here. And also, I kind of like having them in different places, different files, because of, I mean, the vertex doesn't use the colors and this doesn't use this, so they are very separate. But yeah, anyway, maybe I'm not thinking in Vulkan. We are now going to compile this into SPIRV bytecode using the slang C program. Oh. Interesting. Create a compile bat file. Okay, cool. I mean, I guess we have both the exe file and this. This is just a compiler, which the bytecode should be the same, either if we're in Linux on Windows. I'm gonna copy this. Does that say it's copied or? Okay, and then I guess we'll do like compile. Actually, I'm gonna do runic. And I'm going to call this and this will be source. Is there any difference in it otherwise? Doesn't look like it. No. Okay. So that outputs to slang SPV. Okay. Interesting. So let's runic that. Expected value actual slash. Oh, damn it. We can't actually. Okay, I'm gonna do link to slang C. Okay, because runic doesn't actually allow. Also, we need to do this for everything. Oh man. All right, there we go. Runic doesn't allow you to call. Cannot open files. I mean, we could we could link, maybe instead of linking that, we should have like Vulkan. Do we have slang C actually? Wait, we have slang C. Okay. No, we don't. Why can't you open? Oh wait. It's called GLSL. Sorry. Okay, there we go. Slang. Yeah, okay, so we got slang SPV. Cool. Great. Step completed. Blah, 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 blah. Okay, end of platform specific instructions. These two commands tell the compiler blah, 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 at the time when actually if your shader contains a syntax error, it didn't. What is this? Compiling shaders commands CMake function. The best path, and one we use in this tutorial, is to create a CMake function. I don't think so. Get me out of here. Loading a shader. Okay, here we go. So it's simply loading in the file. It's simply loading in the file. So that we can do that. Okay, it's loading in the file. Actually, it's loading in the bytecode. Okay, so we're loading in the bytecode. Let's do that. Let's go to our thing. And let's go over here. Create graphics pipeline. So, well, now we need the I/O as well. And we simply need to read in this file, which is going to be just see if I remember this correctly here. It's gonna be like IO file. No, it's gonna be like dir read file IO. Is this a pointer or not? No, it's not a pointer. Subpath is going to be source. No, it's going to be slang SPV self allocator limit unlimited. There we go. So that gives us the contents, or the, let's just call this the SPV. Cool. All right, so we have the byte array here. Now what? Shader code. Oh, I see, that's what they call it. Anyway, creating the shader modules. Before we can pass the code to the pipeline, we have to wrap it in a shader module object. Let's create a helper function, create shader module to do that. Okay, let's create this function. No discard. Interesting. Shader module. This gives us a shader module. Okay. And you are a code. All right. Now, there we go. There's our little function. Thank you, Piano. Good luck yourself. All right. The function will take a buffer with a bytecode parameter. Yes. Creating a shader module is straightforward. We only need to specify pointer to buffer, bytecode, length of the bit information is called graph structure. Okay, why do we need all this information? Quite one catch. The size of the bytecode is specified in bytes, but a bytecode pointer is a thing rather than a char pointer. Therefore, we will need to cast the pointer with reinterpret cast as shown below. When you perform a cast, you also need to ensure that the data satisfies the alignment requirements. Like it was a data stored in a vector where the default allocator already ensures the data satisfies the worst case. And blah, blah, blah. Let's just copy this, see if we can make sense of this in Zig here. So we have the create info. Oh, good. Now they actually call it just create info, because it's silly if we already know the shader create info module create info code size and the pointer. Okay. So size, so that's the byte size. So it's simply going to be code.length. Reinterpret cost into the thing. This is interesting. So, because we have "9 hours, take a short break for your eyes." Yeah, thank you. I mean, this is usually how long I mean, after stream, I will sit by the computer all day anyway. But I will, okay, maybe, you know, this is getting a little bit late here, but usually I'm just into this. I'm just too much into this to stop. Because it feels like we're already done now. We're like, it feels like we're like 90% done. We'll see. Okay, this one is just gonna be like, so the code. Why can't? Oh yeah, code P code is a U32. Binary code of size, code size, right? So this is the code size. It has other things as well, but I guess we don't need this. So that's going to be the code, except we need to realign this somehow. I guess it's going to be like a pointer cast. Pointer, maybe? I don't know. Okay, so that's our create info. And then we simply call this with shader module. No, we just create this struct here. Oh, I see. So we simply return, wait, hang on, device create shader module. Okay, so this is the same thing here. Actually, that gives us the shader module. Okay, good night, Piano. Thank you for the concern. Alright, so there's our shader module. I mean, we only have one shader anyway, but okay, whatever. Create graphics pipeline. It's like they try to kind of give you like programming tips at the same time as trying to teach you about Vulkan. But anyway, shader module equals, okay, so we simply call shader module for that. So shader module, create shader module with SPV. Whoops. All right, there we go. What do we do with this? Shader, yeah, shader stage creation. Okay, to actually use the shaders, we'll need to assign them to a specific pipeline stage through pipeline shader stage create info structures as part of the actual pipeline creation process. We'll start by filling in the structure for each vertex shader, again in the create graphics pipeline function. Okay. So this is a pipeline. I'm gonna do this. Vert shader stage info is a pipeline shader stage create info. Stage is vertex. Module is the thing we have. The name vert main. There we go. There's our thing. What now? Yeah. Okay, I don't care. Let's do this. There's one more optional member which don't be smear. I don't care then. I just want to get this done. Okay, fragment shader stage info is pipeline frag create. No. Oh, it's the same shader create info. Yeah, it's the same thing. Stage is now a fragment bit. True. Module is a shader module. Still, p name is fragment, I think. Let me just double check that. Yes. Cool. Actually, yeah. All right. Now we have those two things, and that is our stages. So let's just call this stages. This is what they want us to do. So I will just say that this is a list of vert info and a frag info. There we go. Hopefully, I hate it that it makes it into a tuple. Like, I want to make this into, let's make this into this. I mean, I don't hate it. I kind of, it's like, usually what you want is not a tuple. I would say. I think more likely you would want a list. So, and I'm not sure if you can like easily cast there, but okay. Now we have this list. Okay, so we're not done yet. Fixed functions, all graphics APIs user provided, several graphics pipeline, Vulkan, you have to be explicit about all pipeline states, is baked in the immutable pipeline stage. Obviously, in this chapter, we'll fill in all the structures to configure these fixed function operations. It's dynamic state. Well, most of the pipeline state needs to be baked into a pipeline state. Well, most of the pipeline state needs to be baked into the pipeline state. Okay. A limited amount of the state can actually be changed without recreating the pipeline at draw time. Examples of the size of the viewport, line width, blend constants. If you want to use dynamic state and keep these properties out, then you'll fill in a dynamic structure. This will cause the configuration of these values to be ignored, and you will be able to and required to specify the data drawing time. This results in more flexible setups and widespread for things like viewport and scissor state, which would require. Okay, so I'm guessing we don't really need to do that. Vertex input describes the format of the vertex data that will be passed to the vertex shader. Okay. Input assembly. This was one of the main things. Describes what kind of geometry will be drawn, point list, blah 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 blah. Just show me what we need to do. Input assembly, triangle list. Okay. Oh. So do we just put it here? Input assembly. Topology, triangle list. Okay, that's it. See how much nicer it looks in Zig, by the way. Okay, viewport and scissors. A viewport basically describes the region of the frame buffer that the output will be rendered to. This will always be the full screen, and it's the tutorial will always still be the case. Okay, so I guess we have to have this, so let's viewport is a viewport, and we'll have like width. I mean, we have the extent. Is that the same? F32. Oh, it's different now. But we can actually just do this, so that's fine. Max depth, min depth, x, y. We have to specify all of these. So x and y is 0, I guess. I don't know about depth. Depth is, I guess, 0, 1. 0, 1. Okay. Is it min first and then max? Maybe. I'm gonna guess because that's larger. Okay, that's our viewport. Blah 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 blah. Scissor. Do we actually need this? Welcome back, Mabdo. We're on a roll here. I'm still going with the old one because, you know, whatever. Do we need a scissor? What the hell? We specify a scissor that covers it entirely. When opting for dynamic width, you need to enable. Do we actually need a scissor? I'm just gonna skip this. Viewport state. So okay. Right. Yeah, I'll skip the scissors. I'll create this viewport state though. Yeah, I'm kind of getting the hang of it now because it's like it's following a certain pattern. So this will be the viewport state, pipeline viewport state, create info, viewport count is 1, p viewport. Okay, this one actually we need to do something like this. Scissor count. I don't think do we actually even need to specify it? No. So there we go. There's our state. There we go. This is not for anything. That is out of the window. Yeah. So I mean, yeah. I'm just trying to get the triangle up. It's like the most basic. Like we don't even have a camera that's moving around or anything like that. So, you know, it's just the most basic thing. So I'm just trying to get through this because once I get the triangle up, I'm out of here. I'm gonna mess around with the fragment shader, but other than that, we'll be done here. Because I've been at it this for like 9 hours. You set structs data via create infos and that build. Yeah. Yeah, I've seen that pattern over and over. Yeah. rasterizer. It was just I was struggling at first with getting the actual thing to run at all, and to get a window up and get the Windows compilation going and all that. That took a long time to get right. But now once that's up, we're just following this pretty quickly now actually. So rasterizer, blah blah blah, takes the geometry, yes. Okay, so this simply tells us like we're configuring the rasterizer. Great, let's do that. Rasterizer. So rest create info. Rasterizer state. Yeah. Depth clamp enable is false. Okay. Rasterizer discard is false. Polygon mode is fill. Call mode is back. Front face clockwise. Depth bias enable false. Line width is 1. Cool. Nice. Most basic thing is the same as the most complicated scene. It's the same results. I don't know what you mean by that. But yeah, it's I mean we're kind of skipping a lot of things that you probably can do to like modify a lot of super custom things, but we're just trying to get the basic thing up. We're not even using a vertex buffer here. It's like hard-coded into the shader. But I think we still need to say that it's gonna be 3 vertices somehow at some point. Yeah. We're setting all this shit up, and then we'll see how this works here. So rasterizer, blah blah blah. Yeah. Multi-sampling. Okay, fine. Let's keep it disabled. Do we even need it then? Do we even need to create this thing here? I'm gonna skip this for now. Depth and stencil testing. We don't need to do testing. Color blending. Blah 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 blah. Do we need this? I'm just gonna skip this here. I mean, is this like what's determining what the color is gonna be if you have the fragment shader says 3 different colors for the vertices, and then it's blending those in between. Is that what this is? Like the pixels in between the colors. Okay, whatever. So in that case, we probably need this. Maybe. I'm curious to see what's gonna do if we don't have it, or we might need it for something. Color blending, like we have to put this somehow somewhere. Attachments, logic enabled. You're now setting up the pipeline how the GPU will draw. Yeah, I understand. I understand like that. It's just like all the different parts is like how I'm understanding each and one of them, like what they actually do and stuff. Like this blending thing, I'm just gonna think if how that's gonna look. It's gonna be interesting to see what it's gonna do if we don't have it, or even if we can have without it. Okay, so the pipeline layout. You can use uniform values shaders, which are global, similar to dynamic state variables. You can change the drawing time to alter the behavior of shaders while them to recreate them. They recommend to use past transformation matrix to the vertex shader or to create texture samples in the fragment shader. You need all of these for the big struct of pipeline create info. Okay. So there's not like you can set something to null or something to skip it. Okay, let's just create all of them. Sure. Multi-sampling. Did I do that? No, I don't think so. Okay, let's just do all of them then. Well, let's do this. Multi-sampling. Multis, create info. Restoration samples, E1 or 1. Sample shading enable is false. Alright, next thing is the color blending. Which is going to be this guy. Attachment. State. Blend enable false. I mean, if it's false, then okay. So here we have like R is true, G is true, B is true, and A is true, and that's it. Why is blend enable false? Okay, anyway. If blend enable, then we do some blends thing. Okay, this is pseudocode, so I don't know why this is important here. Most common way of blending. Okay, fine. Like, where do we put this? Like, this isn't even a thing. Alright, so we'll have something over here. Color blend. Wait, this is the same thing. Oh, I see. This is how we actually supposed to do it. Like, why do they do this? What? Yeah, this is weird. Okay, source color blend factor. Source alpha. Destination color blend factor 1 minus source alpha. Blend OP is add source alpha blend factor 1. Destination alpha blend factor is 0. Alpha blend operation add. Color right mask. Okay, there's that. Then we have color blending. Color blending. Color blend. State create info. Logic OP enable is false. Copy. Attachment count is 1. Attachment is going to be color blend attachment. Actually, you know what? I'm not sure if we can do this because this is isn't this like a stack variable? Or maybe it's like a one-time use. As long as we use it in here is fine, but okay. I mean, I was thinking, I know that this is a stack variable, but this here is like a temporary array. Anyway. All right, blah, 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 blah. Pipeline layout. Okay. Here we go. Pipeline layout. So, pipeline layout info. Layout create info. Set layout count 0. Push constant range count 0. Okay. And then pipeline layout is gonna be device create pipeline layout. Pipeline layout info. No. I'm guessing we need a try as well. Alright. So there's our pipeline layout. If it's the final form, I don't know, because the tutorial will change things later. Okay. Okay. So here we go. Here we go. Here's the big one. All right. This is going to be the pipeline create info chain. Okay, I see. So instead of doing the chain, because I don't think this has, we don't have that. We need to do like the create info. That's the graphics. Pipeline rendering create info. So first we have the graphics pipeline create info. Which has all of these things. Except we need to have stage count, stages, vertex input state, assembly state, viewport state, test, multi, oops, color blend, whoop, dynamic, up, render pass. All right. Okay, so that is that, and then we have the whatever that was called, pipeline rendering create info, pipeline rendering create info, color attachment count is 1, color attachment formats. Format. All right. And we'll also then set the next two graphics pipeline create info. So that creates our little chain there. Now we can remove this. All right, there we go. Shader stages. What? Where does this come from? Oh, I see. I called it stages. Okay, there we go. Shader stages. Shader stages. There we go. Vertex input. Wait. Vertex input state. Wait, what? Input assembly viewport state. Right. Rasterizer, multi-sampling, color blending, dynamic. We don't have dynamic state. Can we just set this to null? Layout. All right. Okay, the input state. Did I miss that? Vertex input. I might have missed this here. Okay, so they're like just saying that you create this. How do we use this later then? Or how do we create, like, use it? Or vertex input info. Okay, I guess we'll just create it like this. And put it there. I could call it just vertex input, it's fine. Okay, so render pass. You are null from the start, so we don't need to specify that. You are unused. Let's just do this so that we can get a format going. There we go. Cool. All right, let's go back. Okay, we have this. That was a quick page. Begin rendering function to start rendering attachments. Are you saying that we store this thing, or how do we use this now? I guess we'll go here and we'll see. So this is the structure chain that we created last time. Yeah. So why are we going through this again? Dynamic rendering instead of a traditional render pass. So is that the render pass? Wait, okay. Dynamic. They're saying using the word dynamic. I don't like this. Maybe because I skipped the dynamic thing. Okay, let's just follow this. Let's just follow the thing that they want us to do. Dynamic rendering. Is it because we have dynamic state? Fine. I'll do everything here. Dynamic. Vertex input. So after the shader stuff, we'll have this Wait. That's a vector. Dynamic states? Count. I see. So I'm gonna use 1 instead, and the states is going to be viewport, right? Yeah. And that's it. All right. All right. We have our dynamic state. Let's go back again. Blah, 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 blah. Structure chain, yeah. Format. Okay. 2 more members. Vulkan is a great graphics pipeline. Pipeline. Here we actually create the pipeline. All right, let's do it. So is that, do we store that? Yeah, we add it as a class member. Okay, so this is the thing we want to save. The graphics pipeline. I guess we could just call it the pipeline, maybe. I don't know. I don't know if we're gonna have multiple pipelines. But okay, this is gonna be a pipeline. Self pipeline graphics pipeline equals, I'm gonna guess it's device create pipeline graphics pipeline pipelines. It's just called pipeline. Pipeline cache. I'm confused again. Is it there a function just called pipeline? Destroy pipeline, get pipeline, merge, bind, create, compute, graphics. Can we do it on instance? No. We can't do anything here because this doesn't work. Okay, so do we need a cache here? And I'm guessing the cache needs to be stored as well, maybe. I don't know, what is this? A header? Okay. Or a handler, a handle. Pipeline cache. Create pipeline cache. Pipeline crash, okay. Cache info. I don't know. Let's just create it, I guess. And I guess, yeah, we need to try this. Pretty sure. Okay. So we have the cache. That's just gonna be pipeline cache. They create infos. Wait, these are graphics infos. Okay, now I'm confused. We are calling a function. This is on device. Because these are two different things. This is a pipeline rendering create info. And then the graphics pipeline create info. Is it some kind of version mismatch? Wait, this one only creates for the graphics pipeline. Like, look at this. This one only gets the graphics pipeline. What about the other one? Okay. I don't understand what this is doing here. You know what? So I'm gonna guess this is gonna set P next to this one instead. So that I'm gonna guess that's what's gonna happen. So I'm just gonna do this. I guess we'll try this and find out. So this one will be graphics pipeline create info. Because you only need a list of things and you are null. And then what's this? Oh, is there an alloc version? Is this the output? Yeah. No? It returns a result. Okay, so this is the... So we have to have a buffer, I think. Create graphics pipeline. Oh, reference an optional pipeline cache object. Cache can be used to store and reuse data relevant to the pipeline creation across multiple calls. Okay, so it's optional. Well, it's not optional here though. Well, I guess, I mean, we have created it, so that's fine. How many pipelines do we need? I guess we just need one because we store one. So let's just say, so actually we pass in so we allocate pipeline 1 and we pass those in here. And I guess this gives, you can try, we get a result as well. If result is not equal to success, right? Or is this, yeah. Then we return, then we have to set create pipeline error to result, and we return create pipeline error, error. And this is result. Actually, it's null. Okay. But if we succeed, then we actually have a pipeline. So are we calling this? No, we're not. So we call this, we catch, do the same thing over here, create pipeline error. All right. I'm beginning to feel it a little bit here. Okay. Let's build. The cool thing here is once we've built this, it's gonna read the shader file. I mean, we can compile the shader file into the executable, so we don't have to read it. But we can read it, so we can change the shader files. No, actually, we don't. We have to compile them as well. Well, I guess, you know, we can compile and that's fine. But we can recompile only the shader files, and we don't have to change the executable. Anyway, it's easier to change the executable anyway, but you know. Main 7 expected 2 organisms. Oh, okay. Right, because you want IO now as well. Okay, we've got some issues over here. Pointer cast. Okay. So increases pointer alignment. So I'm gonna do align cast. Is that done before or after? I forget. That may work or may not work. We don't know. Do you need to be... Yeah, these are shader infos. Right? So what's the issue? Seriously? I have no idea a good way of doing this, as you can probably tell. Also, it still doesn't work. Expected this found. Oh, sorry. This needs to be shader stage creating from. Still. Wait, this needs to be const. Okay, but can we do this now? Yes, okay, so you have to have const if you're referring to the, okay, nice. What is your issue? What's your problem? Primitive restart enable. I don't know. I'm guessing it's gonna be false then if, you know, I don't know. Right, we're missing a bunch of stuff. Interesting, these does not appear in the other one, so I'm gonna guess they are like 0 in that case. If they don't have a default, they are usually 0, I guess. We're also missing depth bias clamp and depth bias slope factor. Okay. And 373, we're missing mince shading, alpha to coverage enable, alpha to 1 enable. It's gonna be interesting if this actually, I mean, we could also look up what the actual defaults of these are. First time I see a stream so long. How long is your stream gonna be? I don't know. I'm probably gonna as soon as I get a triangle up, I'm gonna quit. Blend constants. What are you? 0. You are 4 things. Okay. Zeros. Can you do this here? Is this possible? No? Oh. F32, right. 403, you need view mask and depth attachment format, depth stencil attachment format. It's a format. I don't know. Is it the same? I have no idea. Actually, we could just do same as this. Man, there was a lot of these. 406. You are a many pointer to shader stages, and you are a. Can we do this to get that? Yes, we can. Okay. also you can do that. All right. 404 missing things subpass. Okay. And base pipeline index. If VK pipeline create derivative bits set this value is not -1, it specifies an index into create info, so the base pipeline is a derivative of. Okay, so I'm gonna say it's -1, I guess. Even more things. Okay, we have to int cast you. Oh, wait. Let's just let's create pipelines buffer. Okay, and then graphics pipelines can be pipelines buffer 0, right? And then free pipelines buffer. There we go. All right. Now, did we call this? I think we did call that. So if we run this now, what's gonna happen? What do you think? It's gonna crash, of course. File not found. File not found? Oh, it didn't find the file. Slang SPV. Oh, because the file is like not... Okay, I'm actually calling it. I have to stand in the thing, in the file, in the thing. There we go. Okay, so we still get this white background, but we're getting a leak from somewhere. This one. Oh, I guess. Can we get rid of this, or do we have to? What's gonna happen? Let's just see if we can free this. I'm not sure how happy that's gonna be. Either they copy this or... Okay, I guess that's fine. Cool. Alright, so there we go. Now we can continue with the tutorial. So we have the pipeline, I think, now. I'm not sure what's gonna happen with the other thing that we had, but okay. Dynamic rendering. We can now render directly to image views without creating frame buffers or render passes. Okay. Introduction to dynamic rendering. Simplifies the rendering process by eliminating the need for render passes and frame buffer objects. Instead, we can specify the color depth and stencil attachments directly when we begin rendering. This approach offers several advantages. Simplified code with fewer objects to manage, more flexibility in changing attachments during rendering, better compatibility with modern rendering techniques. Let's see how this works in practice. We'll be using the rendering attachment info and rendering info structures to specify our attachments and rendering parameters. In the next chapter, we'll create command buffers and record rendering commands. Here's a preview of how we'll use... I don't care about previews. What's the point of this chapter? Okay, let's just skip to the next chapter, I guess. We need to create a command pool. Okay. Here we go again. Oh my god. Please let it end. Okay, create command pool. Almost there. Right. It's probably gonna be some kind of error in here. So we have create info. It's gonna be command pool create info. We have flags, reset command buffer. We have queue family index. Yeah, I think so. I think the name is weird sometimes, but I think that's what we have. Okay, there's our little info. Oops. And we will. There are two possible flags. Transient. Okay, I don't care. I don't care. I just want this to be done. Command info. Command info. Begin, buffer, allocate, destroy, end, free, get, reset, trim, destroy, create command pool. Create info. No. Alright. So there's our command pool. Do we have to store this in a member or? Okay. I guess command pool. Yeah. I think yeah. Well, we have to store it. So it's gonna be like self command pool equals this. All right. Command pool is a command pool. So there's our command pool. Now we do something else. We command buffer allocation. This is also a member, I think, yes. Command buffer. It's probably going to be something similar here. So command buffer, create info is command buffer, create info. Wait. Huh? It's different. It's the alloc info. Command buffer allocate info. Command buffer allocate info, not create info, but allocate info. Okay, fine. And you have command pool. It's gonna be self command pool, level, primary, command buffer count is 1. All right, and then command buffer. It's gonna be move. So I'm gonna guess we're gonna get buffers somehow. Create buffer. Create command buffer. No. Create buffer. Buffer create info. Allocate command buffer. Okay, so it's called allocate command buffers. Allocate info. Okay, so technically it's allocate info, and here are the buffers. It's a many item pointer to a command buffer. Do we have to create this ourselves? Or what are you doing? What are you doing? You're allocating... And that has to be like... out of memory. Okay, so you are allocating. So how? Command buffer count is 1. So we know how many there are. So I'm gonna guess we could probably do like a pointer cast, maybe, here. But they're also moving front the thing. I don't know. Let's try it. It will probably crash and burn if we did something wrong here. But we'll do that. I will see. There's probably compiler errors. Yes. 450. Try. Okay. So there's that. Create buffer. Yeah, I knew it. I knew it. Let's do a pointer cast. Cool. Okay, because there's only one buffer, so we only need one item. So we could just pass this as a pointer, because this expects a buffer. It's weird that it says allocate though. I mean, I guess there could be underlying things in the buffer that needs allocation, I guess. Oh, I see. So these are handles into the actual buffers. I see. Okay. So we get buffers, so how do we know how large they are though? Like, we can't say how large they are here. I don't know. Anyway. Let's continue. Primary, secondary. Okay, I don't care about. I don't care. Record command buffer, image index. Writes commands we want to execute in the command buffer. Cool. Transition image layout. What the hell is happening here? Okay. We'll now start working on the record command buffer. The command buffer will use advanced parameters as well as index of the swap chain image we want to write to. Okay, so why is it only the index here? But I guess we already have the buffer, like we have it on the on the member. We always begin recording a command buffer calling begin with a small begin info structure as argument that specifies some details about the user of the specific command buffer. We can have one-time submit. Will be re-recorded right after executing it once. Okay, so it's like if it's not dynamic. E-render pass continue. The secondary command buffer that will be in entirely within a single render pass. Okay. Simultaneous use. The command buffer will be resubmitted while it is also already pending execution. None of these flags are applicable for us right now. Okay. Inheritance info is only relevant. Okay. Blah 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 blah. Electricity. Okay. Image layout transitions. Before we can start rendering to an image, we need to transition its layouts to one that is suitable for rendering. In Vulkan, images can be in different layouts that are optimized for different operations. For example, an image can be in a layout that is optimal for presenting to the screen, or in a layout that is optimal for being used as a color attachment. We'll use a pipeline barrier to transition the image layout from... Okay, I actually didn't listen to myself there. Before we can start rendering to an image, we need to invent the internet and the universe. We need to transition its layout to one that is suitable for rendering. In Vulkan, images can be in different layouts that are optimized for different operations. We need to transition its layout to one that is suitable for rendering. Fine. I don't know what that means. In Vulkan, images can be different layouts that are optimized for different operations. For example, an image can be in a layout that is optimal for presenting to the screen, or in a layout that is optimal for being used as a color attachment. Okay. We'll use a pipeline barrier to transition the image layout from image layout undefined to image layout color attachment optimal. A pipeline barrier. So, do we need this? Will be used. Okay, sure. Let's copy this. So, transition, image layout. Oh my god, this format that they have, this is a pure, like, this is like a Visual Studio formatting here. Alright, so we have the image index, which is a... Also, what's up with this convention? Anyway, it's U32. We have the old layout, new layout, source access, no, source access mask, destination access mask, source stage mask, and destination stage mask. Okay. And what do you do? Void maybe? I don't know. It didn't say. It's void. Cool. Can you participate in jams? Maybe. I feel like I'm too slow for jams. I feel like when I'm gonna make a game, it's like I've spent like a week and I haven't really gotten anywhere. But I guess jams kinda, it could maybe teach you to maybe be faster, maybe focus on like productivity more than anything else. I have some jam from Icolonc API. Okay, cool. I'll take a look. I'm not promising anything, but thank you. I will take a look. 2026, July 17th. Oh, that's in 12 days. No, that's when submissions are due. So, a micro game. So has it started? He's a little Colonc. Oh, L Colonc. Okay, I see. Sorry. Okay. Let's see. Is Twitchian? Okay. So has it started, or like I assume it has started because all the details are here. So you can just start whenever, I guess. Okay, cool. We'll see. I feel like I have so much other things to do, but maybe. We'll see. When you end your task, you can rate him. Yeah, sure. Alright, thanks. Let's see. Barrier is a image memory barrier 2 with all this crap in here. Okay. I feel like that's not aligned. Yeah. Okay. Okay, these are simply image. No, it's a U32. Okay. Swap chain images. Wait, are you? I forgot. You are simply that. Okay, so there we go. Image index. Yep. Aspect, mask, base mip level, level count, base array layer, layer count. Alright. I'm confused now. I am confused now. No? Okay, anyway, dependency info. Like they all of a sudden they swapped the conventions here. Dependency info, okay, dependency flags. We don't need to set that. Image memory barrier count is 1. And these will be barrier. And then we call pipeline barrier 2 command buffer. Is that gonna be like device something? What's happening? Where's the error actually here? There's an error somewhere. Function. Ah, I found it. Okay, so I think this is gonna be like self device. Wait. Oh, we don't have self. We need self. Self device. Pipeline barrier 2. That's going to be command buffer and dependency info. And this gives us nothing. So that just does something somehow. Okay. All right. We have that now. Great. Starting dynamic rendering. Before starting rendering, transition the swap chain image to the thing. With dynamic rendering, we don't need to create a render pass or frame process. Okay, you said it like 3 times now. Instead, we specify the attachments directly when we begin rendering. Is it like obvious that I'm going insane from this here? Actually, what was that function? It was called like record command buffer, right? So we need this record command buffer function. Oops, come on, there we go. So record command buffer, it's a void URAU32. All right, and we need self, I guess, as well. So transition, right, so that will be the thing we had. Also, we are calling command buffer begin info is going to be something like this, I think. Okay, and then the whole transition image thing, I guess we'll call this after. Okay. Undefined. Color attachment optimal. Source access mask. Color attachment right. Okay, fine, we'll keep these. And this one is color attachment output. And this is the same thing. Okay. Are you an error? No, you're not. Are you an error? You can be an error. So let's do this. I wonder when this is gonna get called now. If it's gonna be like in a loop or something. I guess we'll find out. Alright, so we got this shit. First we transition image layouts. Then we set up color attachment. So we do this as well. Okay. We have a clear color. It's gonna be clear color value. Oh, this is a union. I guess it's gonna be floats, since we are using using floats there. Float. Okay, so 0001. And then attachment info. Image view swap chain images image index. I think we have that, yeah. And then this is gonna be color attachment optimal, clear, store clear values, clear color. Let's just do that. All right, we have the attachment info, rendering info. I'm not reading like what these do. I mean, at this point, I mean, it's kind of like, I mean, if you just skip everything and just copy the code, you can just, you know, look at that working example. But then it's gonna be also, you know, pretty overwhelming with everything happening at once. And probably you won't really understand what's going on. I mean, I don't really understand what's going on anyway, but okay, so this is 0, 0, extent, swap chain extent. No, I think, yeah, we just use our extent because that's what we have. Dairy count, color attachment count, color attachments. Alright, whoops. Okay, so we have the rendering info. And here we have begin rendering. So you have begin and then you have begin rendering. Begin rendering. Rendering info. You are just the thing that's happening. Okay, cool. Now, what else? Basic drawing commands. Oh my god. Is it happening? Is it happening? Why are we even bothering with the scissor? I don't understand that. But okay. Bind pipeline. Graphics pipeline. Okay. So that is what we're gonna do. So device bind pipeline. Pipeline bind points graphics, and this is graphics pipeline. There's one pipeline, yeah. And then we have this thing here. Yeah, we didn't. They specified scissor and viewport. We only specified viewport. So let's only do the viewport. So set viewport. So this will be set viewport. First viewport 0. Okay, and then we have a bunch of viewports. Wait, why are they like creating a viewport here? Didn't we already kind of have a viewport? Didn't we specify the viewport? Yeah, we put the viewport state here. Okay, whatever. Set viewport. So viewport, set viewport. Alright, let's grab these. You are 0, 0. Self extent with self. I think we already have these. That's it. Cool. Set sitzer, we're gonna not worry about. Oh, and then we have draw. Now what does this mean? All these magic numbers. Vertex count, instance count, first vertex, first instance. Okay. Cool. Self device draw. Oh my god. Are we actually gonna draw something? Okay. Cool. And anything else we need to do? Do any of these return errors? No. Cool. Okay. And then end rendering can now be ended. And now, and also end. So, device and rendering, and command buffer. Nice. Okay, after rendering, we need to transition the image layout back to present source KHR so it can be presented to the screen. Huh. Okay. Oh, I see. We need to do that before we end. I see. Okay. So we need to do that over here. Self transition. Optimal. Present source. All right. Color attachment right. Color attachment output. And bottom of pipe. Okay. Okay, I mean, is it okay? We'll write the code for the main loop, right? Because we're not calling this function yet. We have the command buffer recording thing, but we are not calling it. And image from the swap chain, record, execute command buffer, then return finish image from the swap chain. Okay. Rendering and presentation. This is the chapter where everything is come together. We're going to write the draw frame function that will be called from the main loop to put a triangle on the screen. Let's start by creating a function and calling it from the main loop. Alright, so here's our main loop. So we already have a main loop function which kind of does the same things as we're doing here, except but we need to call draw frame, I guess. Alright, so let's create a draw frame function. Draw frame. Probably don't need this as a pointer, but whatever. Draw frame, and we have the loop somewhere here. Yeah. Draw frame. Cool. Now we're getting somewhere. we're like, okay, now we create a draw function. 10 hours in here. Outline of a frame. The high level rendering a frame Vulkan consists of a common set of steps. Wait for the previous frame to finish. Acquire an image from the swap chain, record a command buffer which draws the scene onto that image, submit the recorded command buffer, present the swap chain image. Well, we will expand the drawing function in later chapters. For now, this is the core of our render loop, not lender loop. Synchronization. A core design philosophy in Vulkan is that synchronization of execution of the GPU is explicit. The order of our positions up to us to define the various synchronization primitives, which tells the driver in which order we will to run things to run in. This means that many Vulkan API calls which start executing work on the GPU are asynchronous. The functions will return before the operation has finished. In this chapter, there are a number of events that we need to order explicitly because they happen on the GPU, such as acquire an image from the swap chain, execute commands, a draw, onto an acquired image to present that image on the screen. Okay, cool. In motion, each of these events is set in motion using a single function call, but all are executed synchronously. The function calls will return before the operations are actually finished, and the order of execution is also undefined. That is unfortunate because each operations depend on the previous one finishing. Thus, we need to explore which primitives we can use to achieve the desired ordering. Welcome to semaphores. I mean, okay. Binary semaphores is used to add order between queue operations. Queue operations refer to work we submit to a queue, either in a command buffer. Okay, sure. Blah 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 blah. Command buffer semaphore. Okay, submit work signal. Okay, yeah. Fences. A fence is similar person. That's okay. I don't really know what a fence is. It's used to synchronize execution, but it's for ordering the execution on the CPU, otherwise known as the host. Concretely, if the host needs to know when the GPU has finished something, we use a fence. Similar to semaphores, fences are either in a signal or unsignaled state. Whenever we submit work to execute, we can attach a fence to the work. When the work is finished, the fence will be signaled. Then we can make the host wait for the fence to be signaled, guaranteeing that the work is finished before the host continues. A concrete example is taking a screenshot, saying we have already done the necessary work on the GPU. Now we need to transfer the image from the GPU over to the host and then save the memory to a file. We have command buffer A, which executes the transfer of fence B, F. We submit command buffer A with fence F, then immediately tell the host to wait for F to signal. This causes the host to block until the command buffer A finishes execution. Thus we are safe to let the host save the file to disk as the memory transfer has been completed. Pseudocode. Okay. Fine, I get it. What to choose, whatever. Create a synchronization objects. I promise. Yeah, I'll just follow what you're doing, and you will be okay. So we need 3 class members, 2 semaphores, and 1 fence. Okay. All right. Okay. Oh shit! I didn't show that. I just realized. But anyway. Okay. Anyway. So they want us to create a bunch of semaphores and fences and stuff. So let's do that. Present complete semaphore is a semaphore. Actually, are you a pointer? Yeah, okay, so we can just set you to null handle actually. You know what? Most of these we can set to null instead of undefined. Except you. I guess you are success. You know what? We could just set you to success instead of null. Yeah, it doesn't actually matter. Okay, and then the pipeline is also null. This doesn't actually matter, by the way. I'm doing it anyway for some reason. Why am I doing this? Please help. I don't know why I'm doing this. I'm doing this anyway for some reason. Please help. Okay, you know what? Why am I doing this? Surface format. KHR. Okay. I don't know what is KHR. Is that Kronos? Why are they putting their name everywhere? Kronos. I was like, what does this mean? But yeah, it just occurred to me. It has to be Kronos, right? Because it's like KHR. They're like, hey, this is by Kronos. Okay, whatever. Render finished semaphore. Null. And then draw fence. Draw fence is a fence. Okay. KHR is Kronos. Yeah. It's just funny that they have to like plaster it all over. Okay. There we go. So Cool. Wait. Yeah, we have the semaphores and the fence. Okay. So now sync objects. Okay. Let's do that. Create sync. Well, I can do this. Device. So we need like device, semaphore, create info is empty, I guess. Allocator, no. Same for this guy. Oh, what? Bing, 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 bang, bing. Draw fence is a fence with flags, so this will be create fence, and it will be flags equals signals. Is that it? Okay. Are you actually a thing? Or do I have to say signals bits? Right, I have to do this bit is true. Right, yeah. Good progress. Good luck, you have to sleep. Oh no, come on, it's already done. It's already complete almost. Hopefully, I mean, oh my god. Do you create sync objects? I guess it's mandatory, maybe. I don't know. Are these right? We have to try. Okay. That's the sync objects. Waiting for the previous frame. All right, let's start with this. We're actually defining the draw frame function now. Okay, so we have a fence. Actually, let's leave that for up there. So fence results. Device, wait for fences. Draw fence. Wait all is true. Timeout. Max. That's a long time. I think, yeah. Depending on the resolution or the unit. So we're waiting for that. And now we have to do if fence results is not success. Then we have a fail. Okay. So I guess this can fail. So we'll return draw frame error, okay, error. We will set draw error or results. Okay. Reset fences. Cool. All right. Draw fence. No, draw frames. So we'll catch, and we will do that. And we'll return the error. Error drawing frame. All right. So that just does that. I guess we have to do more things than that in order to actually draw something. But now we're waiting for the things. Okay, cool. I'm gonna complete this, Blue. I'm gonna complete this in one stream because that's what I said that I was gonna do, and we're almost done. Hopefully, I've been saying that for like an hour, a couple of hours now. But okay, so we have the acquire image. Acquire image. Are they gonna show like a full version of this draw function later? Okay, anyway, let's acquire the image. So we're acquiring the next image. That gives us a index and a result. What actually is this doing? I guess we'll do it on device. Acquire image. Next image. Swap chain. Yeah, that's just this. Timeout. Max into 64. Semaphore is present complete. And the fence is null. Okay. Oh, I see. There could be errors here as well. So we have to check the error actually. So if switch error, if it's a draw frame error, VK error, then we do this. Otherwise, we will just return error. Okay. All right, Penguin. Did it show something on screen? Not yet, not yet. Are you enjoying this? I mean, kinda. I'm kinda, you know, training as well at the same time here. Training my brain. Result, image index, and learning about Vulkan. Hey, we're learning here. After that, we can make a Vulkan application, but probably not. But yeah, that's okay. Anyway, so acquire next image. So what are you actually returning here? We get a result. And what is this result? We have a result and an image. I see. I see. So that means that we need to check the results as well. So this is the acquire. I'm gonna call this image result maybe. Acquire results. That's a hard word to spell. If the result is not equal to success, then we're gonna say we have an error. Is the acquire results. And we have an error. Okay, I think that's it for that. So what do we do with this thing? we get the image index that we can use to record. Hey, now it's all coming together. Record command buffer image index. Do we actually need self here? Yeah, we do, yeah. And this is also a try. Image index is gonna be acquire results image index. Yep. Awesome. You think using vulkan sig binding would make it easier? I am using a vulkan sig binding. I am using one. I think it will be harder to not use it. So yes, you are right. You are correct. I just find it funny that it's still pretty, still pretty hard. I am also translating this from the C++, but that's not really a huge deal though. It's like everything, since everything is like the same version, everything it all works out. Okay, submitting the command buffer. I guess we need to do this stuff here. So we have it recorded. Now we call this, but we have a submit info as well. So let's create that. Submit info. Weight semaphores count is 1. P weight semaphores is going to be percent semaphore. Destination mask. What the hell is this? Oh, we're creating it. Wait. Oh, it's created here. Okay. So, I mean, couldn't we just say we could just create it here, right? So the flag bits. This is just some flags. So it's like whatever this was here. This is color attachment, output bits, true. Is that what it is? Okay, I guess we'll find out. This is supposed to be a pointer to pipeline stage flags. The flags is a struct, right? Pointer. Okay, I guess we'll do this. That's what we do, right? Okay. Anyway. Then we have command buffer count is 1. Command buffers is going to be command buffer. Signal semaphores is 1. P signal semaphores. Self render finished. Oops. Alright. I think that's all. Whoops. Cool. We have the submit info. What does colon does? Is it like C++? Yes, that's from C++. So essentially, it's, if you have a namespace or a class, you use that to access like one of the declarations inside of that namespace or class. So essentially, you can define a bunch of stuff in a namespace and you access those with colon. So in Zig, you would just use dot for that. You use dot for everything. But in C++, you can use colon to access. You can also access, I think it's static members as well. And possibly function pointers. I don't know. Anyway. It's been a long time since I used C++, so you have to forgive me there. Blah 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 blah. Okay, and then we submit using the queue. Okay, I'm gonna say this is device submit queue. This would be the submit info, I guess, and then the fence is gonna be fence, and you can error. Okay, so will this now do anything for us? Is everything set up now correctly? I don't know. Submit the command buffer to the graphics queue. Great. Cool. Subpass dependencies. The section is optional, far more explicit than is necessary. It's optional, you say? Okay. Presentation. The last step of drawing a frame is submitting the result back to the swap chain to have it eventually show up on the screen. Presentation is configured. Great. Let's do that. How is this like? How many lines of code? Okay. We're reaching like 700 lines of code. Hello, Merit C6. Thank you. Yeah, you're welcome to join my Discord as well. It's in my channel links and stuff if you want. Thank you. I mean, you're sounding a bit like a bot there, to not to sound rude or anything, but whatever. Present info. Okay, so this is probably device present info. Or is it in instance? Present info? No. Oh wait. No. This is the thing. Okay. There we go. Wait semaphores 1, wait semaphores, render swap chain count as 1, p swap chains, image indice. There we go. Oops. It's not undefined. Oh, acquire. There we go. Okay. Right. What do we do with this now? We will call present, which gives us, oh my god, we can see the, let's not spoil ourselves right now. Also, our triangle's not gonna look like that because I changed the colors. Did you write vertex and fragment shader? Yes, I will show you here in a second there. And we'll mess around with the fragment shader, but then I will call it here. So result is equal to percent device percent. Okay, I guess it's gonna be like q percent, because q is part of the thing. Q percent info. That is the thing. Also, this can be an error. If results not equal to success, we will do some stuff. Cool. Okay, let's now. Oh my god, I'm actually insane right now. Okay, we have a bunch. We have a couple of things here. Invalid format. Where is this happening? Probably over here. Oh, I see. I removed this part. Yeah. Okay. What about draw? Draw frame. Okay. Actually, this is draw error. I just realized. Okay. We got some other errors. Image view, found image. 492. Oh, so these are the image views, not image. And you are dynamic, right? So we're gonna get items, and then there we go. Missing struct fields. Resolve mode. What the hell? I guess it's like everything is false. Resolve image layout. Undefined. I don't know. 0. Sure. Missing struct field. View mask. 0. It's always 0, I think. 533. Error union ignored. Fine. Whoops. 604. What's happening here? Expected blah blah blah, found blah blah blah. Okay. Are you happy now? Uh, 101, return error. Right, because you can error. And then I guess also you can error here. I feel it. Oh my god, that was pretty quick. Okay. Are you ready? Are you ready? Oh. You, of course you don't see it because I'm using, okay, anyway. You're not seeing it, right? You're seeing it like a white thing. A white screen, right? That's not what I'm seeing. But I will, let's, oh, there we go. Oh my god, okay. How many hours are we in here? We are 11:24:50. Okay, 11:24:55. I'm gonna say that's my personal record. My PB for Vulkan triangle. Oh my god. But you can see it now, right? It's not white anymore. It was like the issue with the white was that it was like an OBS thing. Okay, cool. Oh my god. We got it working. I'm gonna try this fragment thing, shader. So as you can see here, the fragment determines like the colors and stuff. So we always put, you know, red there. If I put this here, now I actually need to recompile this. So there we go, and then we can run this again, and now it should be wait, you can't see it. Okay, let me hide everything, and there we go. Can you see it now? Yes, now you see it, and it's now yellow. Okay. So we can simply change this here, and I recompile the shader, and then it will change the thing. So that's pretty cool. Now, how to actually do this? Do we get the thing here as well, like the vertex ID, or do we get like the UV coordinates, or can we access the UV coordinates somehow? Yes, I will see here. Let's see. Where was the thing? We'll go back to the browser, and we'll go back to, I want this sort of thing, because that's what you want. Oh, device wait idle. Okay, sure, we'll add that as well. But I want to go back to render had multiple frames in flight. No, we're done. We're done. Drawing a triangle, set up. Where's the shaders? Fragment shader. Here we go. So essentially defining a bunch of colors. I guess we can do it here. Okay, a bunch of colors. So these are, you know, red, green, and blue, I think. And then the thing here, that's the vertex output. I don't think we need to do anything there. Wait. Oh, so you get like pass through. I see. So are we doing this actually? Yeah, we are, but we need to add the color here. So float 3 color is, wait, what the hell is this? Position. Okay, I guess this is just the color. Is that the default value or something? I don't know what that is. And so here we have to set now output color to be colors ID. Okay. Cool. And then we get the vertex output invert, and the color is the color, and here we can say use a overload here to pass in the color of the invert to make a color there. And then we will compile here, and I will rerun, and there we go. Ugh. Oh my god. It's a triangle. It's a triangle. I'm immediately thinking, okay, how can we make this into a cube? Because, you know, you could put like 15. No. It took 12 hours. Only 12 hours. Yeah, it has been a roller coaster. I think the first 4 or 5 hours was just getting the window up through all the layers of WSL, Windows, GLFW, that libraries and all that shit. They call it the Hello World of GPU programming. Yeah. I mean, I've done it before in OpenGL, and that was way easier. I mean, I guess I was using WebGL, which I'm not sure if that's even easier. Maybe it took me 5 weeks. I mean, to be fair, you helped me a lot in the beginning. You helped me a whole bunch, and then I was reading the tutorial, and I was basically just skipping through. Like, I haven't read half of it. Because I was just trying to find the most essential bits. But yeah, I mean, you're saying 5 weeks, but you know, how many hours do you think? That's the thing. But yeah, cool. How do you make a cube? I said that I was gonna. Because I saw like triangle somewhere. There's a triangle. There's a triangle list. So it's like, okay, I guess we have to do 2 triangles. There's two triangles to make a quad, right? I wanted to learn every piece of code. Yeah. I use Socol. I want to check Socol out at some point. But yeah. So there's like triangle list, triangle strip. So these are the things that I'm actually a little tiny bit familiar with, like the strip and the fan. I actually don't know all the differences here. I'm not sure what the difference is between this and the other one. A cube, you need projection matrix and a view matrix so you can spin it. Oh, sorry, not a cube. I meant a square. A square is what I meant. Yeah, 2 triangles for a square, or a quad, as some people say. So I guess if we go to the shader, we put some more coordinates in here. So this will be like, we have one at the top. No, we'll have 0.5. Can we do like top left? No, wait, top 0.5, right? Or is that, no, it's mathematical, I think. Right? Is the Y flipped on GPUs? Or is it not? Hold on. Left. No, that's negative. Alright. Yeah, I'm gonna draw 2 triangles. That's what I think. Now would you just see the face of the cube, so it should be as, okay. Yeah. Yeah, I meant a square. So we'll have 4 points. So the first one will be top left. I mean, we really don't need. Yeah, so this will be like top left. Wait, no, it's the other way. Top left. Bottom. Wait, it's clockwise, right? So this would be. I think. And this would be like. No, we need. Yeah. We need like right. Bottom, I think, and then left bottom. I mean, we just need both of these here. Whatever. Let's just make it easier for ourselves. We don't really care about optimization at this stage. So that's one triangle. Now the other triangle is gonna be left. Let's just continue here. Left top, right top, and bottom right. I think. Right? Okay. And we'll have vertex ID. That's the position. That's still the same. Now this one is different because we need to do. Oh no, we don't have like length here, so we have to do like 3. Hard code that. Right. Okay. Well, I guess if we want to match the colors up. Yeah, now we need 4 colors actually. We need 4 colors. Yeah. I'm using 6 vertices. That's like because otherwise, as you said, I need like index stuff. But okay. I mean, we're not using vertex buffers or anything like that. Yeah. I need to update the draw function, yes, because now we're passing it 3, so now we should be seeing something at least. I think. Draw frame, and then there's a draw call somewhere. No. Where is it? Percent. No, it's the command buffer, right? It's in here. Right? Where's the draw? Pretty sure. Or maybe it was draw with. There we go. Instance count. Is instance like, do you have to put 2 there now? I'll try this. Compile, and we also have to compile the program. The colors are set by location of vertex. Yeah, I mean, what I was thinking is like I have to figure out if the color that I'm setting it to matches with the same. Like essentially now we have multiple vertices at the same point. They should have the same color. Like they should have the same color. Like I want them to have the same color is what I mean. But they might not have it because of how I set the colors right now in the code. But okay, so that is now doing the thing, and now we get a thing here. Okay. Does this has to be 2 here? Whoops, that's not what I want. Do we have to have 2 there? Maybe it's the orientation of the vertex. it will call tries. What I think was going to happen is that the one triangle will get one color and the other triangle will get the other color. Shader, and I guess if you want to draw it without having some sort of you know, gap in between, potentially you probably want to use some other like topology, like a strip or something. But there's no thing, there's no here, so I guess what we'll do is we'll make the order the other way around. So we go from left bottom to right bottom to left top, and then same thing. Wait, here. Wait, hang on. Isn't it just... No, we have to reverse the whole thing, right? So, there we go. I think. Yeah, there we go. Because they are culled if they are like in the wrong order. So there we go. There now you can see like how what I mean here. So if we put this to green on the second one, so it's essentially we could make colors instead of having 3, we just put 6 here as well. So right bottom should be this, right top is now a different color, so let's put like, I don't know, purple there. Left top should be the same, but now we also need to get rid of this. Wait. Oh. Okay, I mean, looks a bit weird on the bottom. Okay, well, like the blue is completely obliterated here. It looks like blue is like, it doesn't act like green is, feels like, I don't know if it's a illusion or something. But yeah, cool. Yeah, so we got the Vulkan working in Zig. Thanks for the request. I mean, the person who requested it is not here, I don't think. Wait, or maybe you are. Oh, you get the Sierpinski triangle going. SQF, yeah, I mean most of the people who are usually here are probably asleep by now because they are from India and it's like, I don't know, in the morning for them now or something. Try yellow instead of purple. Yellow instead of purple. Where was the purple? Where's the purple? Here's the purple. All right, yellow. Yellow. Very new to SIG, started a week ago. Okay. Awesome. I mean, how long did it take to rewrite the project in Zig then? I guess a week. Or, I mean, you could have done it more quickly, maybe. You can try yellow instead of purple. Yes. This is a weird effect. Oh, I think it's because this dominates. This color dominates because it is kind of part of the square. It's not really a square though. is because the aspect ratio is not a square. So, but anyway, maybe that's the reason why it looks like that. I don't know. We can also say that if vid is less than 3, else we're gonna do positions wait, can you do... Okay, so the position doesn't... there's no perspective going on, so the Z coordinate doesn't matter, right? But here we can do... I want to do like minus, I don't know, 0.1. What if we do something like this? Okay, so we separated. That's what I wanted to do. That's a bit more than I wanted, but here we can see that the blue is actually, it's not really dominating. It's kind of strange actually. Cyan. Okay, if I put this to cyan, it's gonna be very blue here. Let's see. So cyan is these. Yeah. Yeah, you need projection matrix, yeah. It's orthogonal now, or something. Cool. All right. But that's gonna be it for this time. Thank you very much for joining, and also thanks so much for the help map though, because I probably wouldn't actually have succeeded if you hadn't shown up and helped me with a few things there. But yeah, really cool. We've got this working, and I can try to continue with the camera next time in the game. Let's see if we can, on the Twitch side, we can raid. If I remember correctly, well, I can look it up here. Let's raid. That's weird. It says my follower goal of 190 was completed 30 minutes ago, but then there's no one who's followed for 3 days. Thank you for this. Okay. Well, thank you. Raid L colon Q. Right. Okay. Thanks. Thanks. All right. See ya. Goodbye. Have a nice day or night or whatever. See you next time. L colon Q. Oh, that's a large streamer right now. Or I mean, yeah. Let's see. Start the raid. Bye bye.